Welcome everyone. This is Michael Gibbs. So happy to see you here. I know this morning there were some people that were already on our course, and now we're going to have a lot of fun playing with networking. So I hope you guys are all prepared for a fun day. We're going to get relatively deep. We're going to get somewhere between CCNP and CCIE level networking. We're going to then design a network architecture along with a cloud architecture, along with some disaster recovery sites. And we are going to have a really fun time creating a big end-to-end solution. The reason we're doing this, everyone, is that cloud is nothing more than a virtualized network and a virtualized data center. That's it. That's all the cloud really is. And you know what? There's so much confusion we find on a daily basis between people that really keeps them from getting the kind of jobs they want. So realize the cloud is nothing more than a virtual network and a virtual data center. So let's build one. We're going to start with a scenario. Then we're going to first do the data center and the network. We're going to set up all the routing. And then when we're done that, we're going to connect it to two clouds because this is real life. This is the way cloud architects like me work, and I want you guys to know exactly the process. So my students do this kind of stuff all the time. Now, if you're one of my students, you do a lot of networking, but my students know that the networking is super important. So we're gonna have a lot of networking, so welcome. Fasten your seatbelt. Some of this stuff's gonna be simple, some of this stuff's not gonna be simple, but I'll make sure that you guys get it. You can ask me any question you want along the way. This is not like a video only, this is designed to be interactive. So let's go have some fun. So let me read you the situation for what we're going to do here. And then from here, after you guys all know what we're actually trying to do, then the next thing we're going to do is we're going to design it. So let's actually read you the scenario. Bear with me a second. I had a document that I wrote completely for this, and for some reason I can't see it in front of me. So we're going to go find this document. If not, I'm going to just walk through the whiteboard. Okay, so here we go. Bear with me for one more minute. This never happens. I'm always so set up and super organized. But I don't realistically know what happened. Oh, here we go. Okay, so here's the scenario. Welcome 4D Robotics, welcome Jeannie, Ahmad, Nick, Brandon, so wonderful, SR, thrilled to see you, Sandeep, Amaranth, you guys are my students, I love seeing you guys here, lots of other people, so let's have some fun. Here is the situation that we're going to be contending with. We are going to be setting up a brand new investment bank, and let's say in this particular situation, our investment bank is funded by one of the richest people in the world. And he's given us several $1 billion to design the next generation, highest performance investment bank starting from scratch. By the way, I've been working on architectures like this for the last 30 years. So in this particular firm, here's what you need to know. They're going to be the most technology enabled in the world. They're going to be using an algorithmic trading platform. And on this algorithmic trading platform, they plan on processing a minimum of 2 billion trades per day. They want to do some market making, which is basically where they buy blocks of it and then they sell it to other people. But they also want to basically just trade. They have systems that are going to be bringing feeds in from all over the world. The feeds are going to give tremendous amounts of information. These feeds are going to be running into 100 plus servers. And these are going to be some massive servers with 128 cores. And each one of them is going to have a large number of GPUs. What's going to happen, we're going to take this information. We're going to do some machine learning and mining on this application. Now these systems are set up by someone else, so we don't have to do any work with them. But we're going to take these systems, and these things are going to process trades. And they're going to be big, big servers. And when they process trades, they're going to make money on every single trade, mostly speaking. Now, when we're building this, there's a competitive advantage in the financial industry to be first. What do I mean by first? Let's say there's some good news going on right now about Cisco. Cisco releases earnings. Let's say they're good. I have no idea. I'm just making it up. The second Cisco's earnings come out, if it's good, people try and buy the stock, which means we all buy. And the first person that buys it at the cheapest price. The next person buys a little more expensive. The next person buys a little more expensive. You can be dealing with $10, $20 difference by the time it's said and done. And when you're processing 2 billion trades per day, and you're buying blocks of 1,000 stocks, even 5 cents matters. Or even a penny matters, especially when you're doing this 2 billion times per day. So, big computers, latency sensitive, and a nanosecond matters. In fact, the organization's done some really good ROI modeling. And they've told us that for every millisecond that's gained in terms of performance, there is a $500 million competitive advantage to their business. So I'm going to say this one more time. For every millisecond that we can save, it's a $500 million per year. So if you had, for example, a VPN connection that has 30 milliseconds of latency over this VPN, that's $15 billion of lost money per year. So when we're dealing with these environments, we're going to have the super highest performance, lowest latency, lowest IOPS, highest performance networking in the absolute world. And I've been doing these systems forever. And some of these systems, you can't put them on the cloud. Why can't you put them on the cloud? Well, let's look at it this way. If it takes you 10 milliseconds to cross the cloud to get to the cloud provider with a direct connection, that's $5 billion of lost earnings per year. Plus, we need IOPS in our disk. We need them so fast, and we need about 1,000 times the performance than we could actually get in the cloud. So we're going to have to do some really cool engineering in our data center to do this. We're going to have to do lots of optimized routing, lots of optimized switching. We're even going to have to play with cable length. We're going to have to optimize our operating systems. This is going to be a big end-to-end design. But we also have other challenges we're going to have to deal with in this project. We're going to have to deal with a customer-facing website. And in this customer-facing website, people are going to basically be looking at their portfolios. And you know what? Our customer base, because they're private clients, have zero tolerance. An extra millisecond of delay, 2 milliseconds, 10 milliseconds, will drive our people nuts. If we can't get them the best experience, they're not going to go with us. They're going to use Goldman Sachs. So we've got to be better than everyone. So we're going to be using a few hundred web app and database servers, but nanoseconds count. Now, because we have customers on our website, and I told you that our customers don't want to wait for anything, that they're all like CEOs and really rich people, and they're not going to wait for anything, we've got to make this website lightning fast. And a part of that means that we're never more than one ISP hop away from the destination. So we're going to have to do some really cool routing things here to make this happen. Now, I got to tell you, the organization is paranoid about security. I mean, ultimately paranoid. And this organization will literally do anything to make sure they're locked down. So when we design this system, money is no object, none whatsoever. Now, this organization does have a desire to be partially in the cloud. And what the organization said is, we want the best design at the best performance, and we don't care about cost. They were told this. A millisecond equals $500 billion a year. So they said, if you can spend $200 billion to basically get, or $200 million to save a half millisecond, it's highly profitable for us. So do it. So that's now you know the requirements for this. And we have to have a super high security system. We're going to be dealing with financial advisors with voice over IP, VPN, so anything that we can do to make it best matters. Does everybody understand the requirements so far, what we're trying to deal with this complicated situation? If you do, type Cloud Architect, and I'll let you know, because now we're going to, if you tell me Cloud Architect, I know you're awake, alert, and oriented, then we're going to get into design. Is everybody with me so far? Let me know with the Cloud Architect in the chat box, so I know you're here. John Oho, absolutely, this will be available, as my associate Chris said. Welcome back. You were on the call this morning, and we love having you here. I'm not sure. Okay, John Oho got it. Francisco got it. Keep letting me know you're there, and then we're going to get involved in some serious, fun networking design. Sandeep, Leo, Aladdin, wonderful. Paula Dean, interesting. Nick Love, Augustine, good to hear from you. Been too long, I think, since we've spoken. If you're the same Augustine, I think. Okay, absolutely wonderful, everyone. So, now, I talked about some really complicated requirements. really complicated requirements. I talked about never being more than one ISP hop away. I talked about extraordinarily low latency. I was told that a millisecond can save $500 million a year at profitability. Now you know the business. And because you know the business, this is where the magic happens. So when I said to everyone, high performance networking, and we'll be sharing our screen when we're driving things, but we're not going to be sharing our screen until we're drawing things. We are cloud architects, network architects as a whole. Architects do not hide in the bottom right-hand corner of their screen. They are directly in front of the customer. So, Omar, we will do this the way we run every cloud architect thing. We will not be hiding in the bottom right-hand corner of the screen. Now, when we draw things on the whiteboard, we absolutely will, because that's the only way you can see it. But we're going to be out in front of you just like the way any cloud architect would do in a real world. Kingsley George, so wonderful. Haven't you? Haven't spoken to you in a while. Jonathan Brown, fantastic. Okay, so now you guys know the requirement. So I'm going to ask you guys all this question. Can I possibly achieve the maximum performance that we're describing in the cloud? Is this even possible to deploy something where nanoseconds count in the cloud, where we might need 5 million IOPS? Can we do that? Let us know with an answer of yes or no. If you think we can, say yes. If you think that we need better performance of the cloud, something without all the overhead of the hypervisors, without all the overhead of being on somebody's shared servers with overprescriptions, let us know. Do you think we can make this high performance thing on the cloud? Or do you think we should do other stuff on the cloud, which is really awesome, and stick the stuff in the data center? You guys want to let me know? Good job, Ahmad. Good job, Sangrita. You can't do this on the cloud, and if you do, it's going to add another 5 to 10 milliseconds of latency. If we add 10 seconds of latency, that's $5 billion lost for this business. So as a cloud architect, you got to know, what do you do, where do you do it, how do you do it, and how do you make it best? So now let's talk about how we can do something like this. So, oh, Coachella Costo, looks like you're from Jamaica. Welcome. We typically have a lot of Jamaicans on these calls. I know we have a lot of them. We've got a lot of Jamaican students. Welcome. Hope everything's Irie for you. So, it is for us around here, and welcome, Coachella Coastal. So, the cloud likes agility. So let's talk about how we design this. So let's talk about how you design a high-performance data center. Well, the first thing you need to do when you're designing a high-performance data center is set up the routing. And we're going to have to set up the IP addressing. So because of this is a 4-hour workshop. We're going to do it all. And yes, I'm excited about networking because I absolutely love networking. So let's evaluate these requirements one by one by one. So we need a low latency network. Does anyone know what that's actually like? Let me tell you. We're going to build a high performance network. And no, we can't possibly build something this performance on the cloud. And I respect all of you, and I love all of you as a group, and that's why we do this. This cloud architect community is wonderful. Half of you guys are here are my students. Let me tell you, when I hear from my students, it is a wonderful experience. So I'm thrilled to be here with you. So let's look at what a high performance network would look like from scratch. The first thing that determines our network performance is as following. What do we need to achieve? What do we need here? We need 5 nines availability, meaning less than 5 minutes of downtime per year. So we need optimal routing, we need optimal performance, and we need a routing protocol that's going to determine if something breaks, how to reroute around it, and how to self-heal. So what are we going to do here? Let's talk about it. First thing we're going to do is we're going to build the core of our network. And yes, Sandeep, we are going to have to use multiple ISPs. You picked that out really great. We want to be, in most cases, not more than 1 hop away. We're going to have to use multiple ISPs. And not only multiple ISPs, we're going to have to do perfect internet routing. So now let's build the core of our network. Redundant routers, redundant switches, redundant links. And this is the kind of network I build all the time, whether it's in the cloud, off the cloud. So the way we're going to build our network is we're going to use the Cisco model, which is the core, access, and the distribution. And these are going to be all layers that you design your system. So in the core of our network, our goal is this. Fast fast. Send those packets around as fast as we possibly can. So what's that going to look like? Let me show you. So this is what you would typically do. Let's say you have a router 1, a router 2, a router 3. We're going to start. We're going to do all network design principles here today, so I expect it to be lots of fun. Understand it's not going to be the simplest thing today, but you guys can watch the replay. This is Cisco certified internet expert level systems design that we're doing today, so I want you all to have fun. So typically speaking, once we design our systems, this is what's called the core of our network. And the core of our network needs the most highly available, high performance, redundant routers and switches. And typically speaking, what we would do in an environment like this is we will typically take a 100 gig connection and we will bundle 4 of them into something that's called like a port aggregation protocol or link aggregation group. And by doing this, this is going to give us 400 gigs of bandwidth between everybody, and it's going to look like a single logical thing. So we're not dealing with multipath routing or any of the complexities which can be done. There's times and places to do that, and guess what? We're going to have fun with it today. We're going to do multipath routing without getting out of order packets. And then typically speaking, let's take this. We're going to basically add another 400 gigs between these 2 switches. Now this is just the layer 1 and layer 2 stuff. We got a lot more to make this stuff work. Now let's take this. 1, 2, 3, 4. Now, in this particular case, we've got some good networking. But now let's say router 2 wants to get to router 3. It can go, let me make sure we got our numbers correct. If router 2 wants to get to router 3, it can go through router 4 to router 3, as you can see. Or what can ultimately happen, and thank you so much, Innocent, love being here and appreciate what you're saying. Or it can go from router 2 to router 1 to router 3. Now, I want you guys to think about it. What happens when you go through one of these high performance routers or switches? Packet comes in, hits the CPU looks at the routing table, and then the CPU sends it out a line cord, which has typically got ASICs and it's really fast. The time that packet takes to go into the device and out of the device might take a couple of nanoseconds, maybe even a half of a millisecond. Millisecond equals $500 million of downtime. Do we want an additional router hop? We do not. So what are we going to do? We're going to fully mesh these things at the core of our network. And by doing this, we're going to add another 4 links between these guys. And then we're going to add some more of these links. What am I missing over here? Okay. Let me just copy one of these. Yep. Well, some days your PowerPoint skills are better than others. Typically we do this in something in Lucidchart. I like Lucidchart. It's a great thing. I typically use PowerPoint on the fly. Because, we business people think in PowerPoint, and architects are half business people. So does everybody see this? Can everybody see that now everybody's got a 400 gig link to everybody? Now these routers, I gotta let you know, they have redundant power supplies. They have redundant line cards, meaning if one cable's on one card, if the card were to fail, that's okay. You got others in another card. If any one of these links fails, don't worry, no big deal. Why do we not have to worry about it? Let me tell you right now. I got 3 more in the bundle, and we got bundles going everywhere. So now we've got the basis of this. This is our physical layer 1 and layer 2 connections. Can we move traffic like this, or do we need to add some, or are we moving traffic based upon IP? Do we need some routing information? Is that what we need to do? Do we need routing to make the communication work? Yes, we need routing to make the communication work. So, what do we do to make the routing work? Do you think it's a good idea to go from router 1 and write a static route to router 2 and a static route to router 4 and a static route to router 3 and then go to all these other devices and add like 500 or 5,000 more static routes and constantly be managing routes? Or do you think we should use something dynamic something that's going to look at the situation, sense a cable cut or router go down, and automatically do it on its own and fix itself for you. Does that seem like a better idea? Let me know if the answer is yes. John Oho, I saw you doing it. Innocent, I can always appreciate all your kind words. Sandeep, you got it. Okay. Koshella, Coastal, fantastic. Koshella, seeing this, I'm going to be making some rice and peas tonight, some jerk chicken and some bami and maybe some turmeric tea. Like the flag, makes me smile. So, good. So Sandeep, Sharma, you mentioned IBGP here. We will be using IBGP here, but IBGP will not be fast enough for our needs. IBGP is slow. IBGP is used to carry a tremendous amount of routing information. So, periodically, that's what I need you to do. 1 second. So, now you guys get it. So we need something else. So what are we going to do? We're going to use a routing protocol. We're going to use an interior gateway routing protocol. Okay, so when we talk about routing protocols, we're going to talk about two kinds today, and we're going to have a lot of fun with this networking. We're going to talk about interior gateway protocols such as EIGRP, OSPF, and intermediate systems to intermediate systems. And we're going to deal with exterior gateway protocols that are designed to connect to somebody else, like BGP. What is the difference? Interior gateway protocols are optimized for speed. They're fast. You get a cable cut, and when you ultimately get a cable cut, they reroute real fast. Exterior gateway protocols like BGP are designed to take 750,000 routes from 10 different internet service providers and carry it. So we're going to use an IGP. So that's why you got to know the different kinds of routing protocols. And guess what, guys and girls? You can't use BGP for complicated things if you don't run an IGP. And the reason you need the interior gateway protocol is your BGP peers need to have network layer reachability information to each other. So we're going to now, basically, we're going to have some fun with this. So what we're also going to do while we're at it is we're going to put a address that we're not going to send out of our network. We're going to call it a loopback address. And what we're going to do is on our routers, we're going to advertise one route, and it's going to be a unique route, and each one's going to have it. So let's say, for argument's sake, even though this is a public address, we're not going to share it out of our network. I definitely need some turmeric tea. Both I love it, and it's also good for my joints. Then we'll call this guy 2.2.2.2. Then we'll go over here, and we'll call this 3.3.3.3. And basically speaking, we'll put over here on this guy. We'll call this guy 4.4.4.4. What we're going to do is we're going to assign a logical address to this. And in the future, one day, we're going to actually do this. I'm going to configure this with you very soon. We're going to take the same design and we're going to actually build it. So look for a future webinar when we actually do this. Chris from my team will make sure that if you want to let them know, he'll invite you. We'll let you know, but we're going to do another one that's coming really soon. And you're going to see a lot more deep networking training coming from us in the next month or so. So be on the lookout for some cool networking fun. So we're going to run a routing protocol called OSPF. OSPF is what's called a link state routing protocol. What is so special about link state routing protocols? I'm going to tell you right now. Here's how they work. Basically, every one of these routers, we're going to put them in specific areas. We're going to call this one Area 0, which has the network backbone. Every router in Area 0 knows the status of every single link in this area. It knows everything. So what happens, all these routers come up and they form a neighbor adjacency. Basically what happens is, hello. These routers send a hello. These routers typically send a hello to 224.0.0.5, which is all SPF routers, and they also send something called 225.0.0.6, which is all DR others, designated routers or non-designated routers, or backup designated routers. We don't need to worry about that for right now. But at the core of our network, we run OSPF and we're running Area 0. Now, why is this so important? It's so important for the following reason. We need speed and convergence for this. So typically speaking, we're going to show you what the rest of this architecture is going to look like, and then we're going to get into the routing. The next thing that you're going to see, so we're going to call this our core. And this is according to Cisco Certified Design Expert, the way you would train, the way we would design them. It's taught to all CCIEs and all CCDEs. We're going to call this the core. And what is the core? The core is your highest performing network. Kind of like the core of your body is between your shoulders and your hips. The core of the network is the largest and strongest part of your network. The core of the body is the largest and strongest. So after that, we add something called a distribution layer. And what is a distribution layer? A distribution layer is a place where you aggregate stuff and then you feed it into your high-speed core. Why are you doing this kind of stuff? Why do we segment our network? Why does anybody use a queue? Basically to decouple their environments, to promote scalability and self-healing and failover. Well, we're doing the same thing. In fact, all the stuff you guys are doing on the cloud now, we've been doing for 30 years on the network, and it's just a standard part of our everyday life. So, not new to us. Old tech. The cloud is just really old tech, but we love it. And then what you're going to have is you're going to have these access switches and routers. So basically what's going to happen is you're going to have these switches at the edge, and they're going to have lots of ports. And these things with lots of ports, they're going to feed into, They're going to ultimately feed in to the distribution layer. And of course, obviously, you'd have some redundancy with your connections from the access layer to the distribution layer. And then your distribution layer obviously will have some redundancy. We're going to feed into the core over here, and we're going to feed into the core of the network. So this is the way organizations designed networks. The core of their network, high performance routing, then a distribution layer, and then an access layer. So now let's start looking about this. So let's layer it up from the ground up. So let's do this. Let's copy this. We're going to remove the distribution layer and access layer. And the reason we're going to do this is we need some workspace to work with. So what we're going to do is we're going to take this stuff all together. I think we're going to group it. And I think if I group it, I can actually shrink it just a little bit. Well, I can't shrink it just a little bit, but I can move it around a lot easier. Maybe I can shrink it. Okay. Well, it's about the best we're going to shrink this. So now we need to connect this to our internet service providers. And granted, there's like a firewall kind of policy that we would typically do, and there's a way we're going to look at it. But let's look at our internet-facing architecture. Does anybody remember the requirement that says ideally they want to be no more than one hop away from their customers when they go to the internet? So in order to do this, let's look at the practicality of real life. I'm connected to AT&T. I want to connect to a company or a website that's on Verizon. I leave my house, I go to the internet. I then go to AT&T. AT&T, in some cases, sends me to Florida Power and Light, and from there, Florida Power and Light deals with Verizon. So I might have to go through 15 routers to get to my destination. We've got executives that have no tolerance for waiting, remember? They won't wait even a minute. They have no concept of waiting. So since they have no concept of waiting, let's do this. Let's make them not wait. How do we make them not wait? We optimize our internet routing. And how do we optimize our internet routing? We have to connect to multiple internet service providers. So now that we're connecting to multiple internet service providers, let's look at it this way. If I connect to Verizon and I connect to Verizon and AT&T, if I don't take in full routes for them, which service provider am I going to use? My default route's going to point me out one. Can we send a default route to two different things at the same time? Of course we can't. We cannot. So if we do nothing, we're going to be using one internet service provider, and that's it. If we want to use two internet service providers, we can have a primary and a backup without BGP. But if we want optimal routing, we have to connect to other internet service providers. And here's how this is going to work. I connect to Verizon, and I get all the routes from Verizon they have in their routing table, which is about 750,000, maybe 800,000 right now. Then I'm going to connect to AT&T, and AT&T is going to give me about 8,000 or 100,000 routes. Then I'm going to connect to NTT Data, a big one. CenturyLink, another big one. I'm going to do this for all my 10 ISPs. Now, let's think about this from an optimal perspective. Connecting to 10 ISPs. If I get the route from 10 different ISPs, what do I have? I have perfect communications and connectivity. So guess what? We're going to do the same thing. We're going to connect to multiple internet service providers. So what do we need to do to connect to multiple internet service providers? Well, for one thing, we need a router that's going to connect to these devices. Should we put all 10 different connections inside of the same router? Even though the same router basically needs, if we put them in the same router, redundant control modules in the router, redundant power supplies, redundant line cards, is that enough availability for a bank that basically told you a nanosecond lost equals $500 million in lost wages? No. So Ryan White, we're going to use 10 internet service providers, and by using 10 internet service providers, we're going to have some extremely good low latency performance. And the reason it's going to work is if I take the route from Verizon and AT&T and NTT and CenturyLink, I now get the most efficient path to the destination. So Ryan, I think you're in Montego Bay. I could be wrong, but I think you're in Montego Bay. The shortest path for me to go from where I live in Florida to you is probably just jumping on an airplane, something I do fairly frequently and love that, but that's neither here nor there. Now, if I went to Nassau, Bahamas, and then I went to Port of Spain, Trinidad, and then I went to Montego Bay, that would not be the most direct path. And that's what happens with internet routing. If I have the link directly to you over in Montego Bay, it's a single shot to your ISP. But if I go to AT&T, it's going to go from AT&T, then it's going to hit a cable and wireless, and it's going to hit another ISP, and the latency is going to be much higher. But if I have a direct connection to you, as an internet service provider, it's going to be faster, Ryan. So Nick, Ryan, I hope you get that. So when we connect to 10 ISPs, we're pretty much never more than one ISP hop away from our customer. And when we do that, latency goes down, performance goes up, customer satisfaction goes up, and yes, it costs us a lot of money, but we don't care. Remember, 1 millisecond equals $500 billion. So we are going to design this for perfection. So I hope you guys get it. We love working with you guys. This is fun stuff for us. This is architecture. So now let's look at this. So if we're going to have these 10 ISP connections, we're going to split them amongst two routers. Why are we going to use two routers? If a router fails, we're in trouble, guys. So, I mean, it takes a lot to knock out one of these, $500,000 core internet routers with redundant power supplies, redundant this, redundant that, redundant the other thing. Ryan, I'm so happy you ask questions. So let's ask them all, because I want you guys to be great. So let's say this is int R1, and now we're going to do the same thing on int router 2. Now I want you guys to really, really think about this. So now, okay, we've got this going on. We've got our internet connections to two different routers, and we're running BGP to these guys. And the reason we're running BGP is a super scalable protocol. We're going to be taking in basically 800,000 routes from 10 different service providers. 800,000 routes from 10 service providers. Oh my God, that's 8 million routes. No. An interior gateway protocol like OSPF, once you get to about 20,000 routes, it starts breaking down. Doreen, thank you. I love when you guys let me know that you're here. If you're here and you're happy, let's type, the cloud networking or cloud architect. Somehow I know you guys are here. We're really trying to elevate the cloud architect community, and networking is a piece of it. So we're going to be running what's called eBGP, or exterior BGP. So eBGP is what you use to connect to an external organization. So we're going to be running eBGP to all 4 service providers on this link, and all service providers on this link. Do you think router 1 and internet router 1 and internet router 2 need to talk to each other? Do you think that might be important? How do the systems on your network know what they need if you're not exchanging routing information? Because let's say you did it this way. If you had a default route from router 1 which sent your traffic directly to router 2, and then you went to router 2 to the internet, that would be great. But what if the best route was through internet router 2? If you're on router 1 and you go internet router 2, wouldn't it be great to go to, you're on internet router 1 on the left side, and you wanted to send your data out one of the internet service providers on internet router 2. If you don't have the best route to it, you won't know. So what's going to happen is these organizations are going to run interior BGP. Interior BGP. Yes, this stuff at some point is going to populate the routing table, Ryan. Right now, we're actually updating something called typically it's the routing information base. And what goes on with this with BGP? We take in the 10 million routes from our people, and then after that, we run the BGP algorithm, which states prefer the one with the highest weight, prefer the path with the highest local preference, prefer the one with the shortest AS path, prefer the one with the lowest multi-exit discriminator, etc., etc., etc. So there's that algorithm, and we can talk to you about that algorithm if you like. We're always happy to talk networking. We love networking, but this is the way you're going to set it up. Now, let's say for right now, so if now router 1, you give it a route to R1, it knows if it needs to go out router 2, we're going to do this. And seriously, make sure you guys, like my associate Chris just put in the window, ask any questions you want. We want you to be great. This is your time. We do this for the cloud architect community. So if you've got questions, ask us. I want this to be a great learning experience for you. I don't want this to be like a Udemy course where basically you're watching it and you're watching a video and there's just somebody talking to you. I want you to learn. So ask whatever questions you need. Let's make this fun and interactive. I love teaching. That's why I do what I do. So let's get you guys great. So if we go from router 1 to router 2, that's great. But if we don't take the internet's routes on our system, can we really, really, really have the best routing? How does router 3 know to send its data to router 1, to internet router 1, or router 2? It doesn't. Unless you inject a default route versus router 4 to router 2. So what you could be doing is you could be setting up something like HSRP, Hot Standby Routing Protocol, or VRRP, Virtual Router Redundancy Protocol. But we want the best. Remember, customer requirements are the absolute best in the entire world. So what are we going to do? We're going to run iBGP. We're going to take in all these routes learned via eBGP, and we're going to run it internally. So at the core of our network, we're going to have super high performance, self-healing capabilities from OSPF. But across our network, we're going to take in the full internet route, so we know how to get our website data to the internet as fast as possible. So let's talk about how we do this. Now, the reason I'm covering iBGP, and we're going to have to use an autonomous system, GoPal, absolutely. Anytime you're using BGP, you're going to use autonomous systems. Now, if you're connecting to the internet, you'll be using public autonomous systems. But internally, you can use private autonomous systems, or connecting between organizations, you often use private autonomous systems. What makes it eBGP? Autonomous System 1 connecting to Autonomous System 2. What makes it iBGP? Autonomous System 1 connecting to Autonomous System 1. That's the only difference. But it changes the protocol. Oh, Io, I'm so happy you're here. Wonderful. So it changes the protocol. So now let's think of some cloud networking things you've heard of. What happens when you do VPC peering? When you peer one VPC to another VPC and a third VPC. You know how they talk about non-transitive? And here's what non-transitive means. I want you guys to truly, truly, truly understand it. And then we're going to get back to the fun BGP. This is what's meant by non-transitive routing, and iBGP is non-transitive. So when you hear Cloud Hub, or when you hear Transit Gateway, it's a 30-year-old technology that's a BGP route reflector. So let's talk about this. So what does it look like? This is non-transitive routing. Let's call this A. Let's call this B. And now, after this, let's add another router called C. So here's the difference between transitive routing and non-transitive routing. And then we'll answer Mega's question. Well, actually, let's answer your question right now. What is an autonomous system number? Autonomous system number is a number that you actually get that just identifies your system to the rest of the world. So when you have a website, you get a public IP address to identify to the world. When you're dealing with BGP, you get an autonomous system. And you either purchase one for a public one or basically use a private one. So realistically speaking. So now let's look at this. Here is what non-transitive routing is. Let's say you've got, let's make it clear, let's add the networking. Let's say you've got this 10.0.0/8 over here. You've got, let's go beneath it, 172.16.0.0/16 over here. And let's say over here on this device, because this non-transitive routing is really important. 192.168.0.0/16. So if A sends its routes to B, and B were to send A's routes to router C, C would know how to reach the 10.0 subnet through router B. This is transitive routing. So transitive routing would enable you to take some data from, let me draw it out for you so you can see it, point A to point B, and then it would enable the information they sent from B to C, and vice versa. Non-transitive routing means the data can go from A to B, and it is blocked. It will not go to C. And the reason it's not going to go to C is as follows. There are no, what do you call it? The routing information is not passed through, because this is what non-transitive routing means. Non-transitive routing means I take a route from one person and I don't give it to anybody else. And because of that, nobody knows how to reach anybody, and you can't do it. So I see Joe White's in Montego Bay. I know Joe White. He's one of my students in the experience program. He attends everything. He studies hard. He's super, super, super motivated. If Joe's in Montego Bay and Rhonda's in California and I'm the hub in between, if Rhonda gives me her routing information and I pass her routing information to Joe in Montego Bay, everybody can talk to each other. But if Rhonda sends me her information and I have it, and Joe sends me his information and I have it, I can reach Joe and I can reach Rhonda, but they can't reach each other through me. So that's called non-transitive routing. And why are we going to talk so much about non-transitive routing? And then Gene, it looks like you have a question. I'll get to that next. The reason we're talking about non-transitive routing is interior BGP is non-transitive. What does that actually mean? By being non-transitive, it means that basically routes from one won't be passed to somebody else. So let's say we've got a small network like this. If we fully mesh our IBGP peers, we don't have a problem. Take it from router 1 to router 3, everybody knows how to reach everybody. But what if we don't want to fully mesh our peers? Why do we not want to fully mesh our peers all the time? Well, I want you to think about this mathematical problem. When you have 3 devices that need to pair, it's 3 connections. When you have 4 devices, okay, how many do we have here? 1, 2, 3, 4, 5, 6, no big deal. But the formula to calculate your peering connections, whether it be VPC peering in the cloud or BGP peering, IBGP, the formula is n times n minus 1 divided by 2. So look at it this way. 100 IBGP pairing sessions times 100 minus 1, which is 99. So 99 times 100, that's going to be a pretty big number, and divide by 2. So if you've got 100 IBGP routers, which is nothing for a service provider, they're going to have thousands. But let's just take it. So we're going to take 100 times 99 divided by 2. So for 100 routers, we would need to set up 4,950 BGP pairing sessions. And if any of you guys think it's a good idea to go to routers and literally configure manually neighbor 1.1.2, remote AS 65531, neighbor 2.2.2, remote AS 6, and do this with every different question. It's crazy. So what do we do? Well, we've got a concept called a route reflector. What is a route reflector? A route reflector is a device that goes back to this concept, and the route reflector is simply this. And I don't know where you might see this in the cloud somewhere else. A route reflector is, let's say you've got your location here. You've got these guys paired with these guys, and we're going to set it up with this way. So a route reflector basically tells IBGP to break the rules of non-transitive routing. That's all it is. So when you set up what's called a route reflector, what you're really doing is as follows. You're basically saying B, who's at the hub of this, who's the hub, and A and C are spokes. You're basically saying, hey, B, advertise my routes from C to A. Hey, B, take my A routes and advertise them to C. That is what Cloud Hub is, connecting multiple VPCs. That is what Transit Gateway is when connecting to multiple VPCs. So when I deal with people that don't know networking, and I say Cloud Hub, Transit Gateway, same technology, and they're like, no, no, no. One's just with VPNs and one with private lines. The tech is the same. It's 30-year-old route reflector technology. When you understand the network, all this stuff is silly easy. So what are we going to do? Well, maybe, just maybe we're going to make 2 route reflectors here. So let's say we take Internet Router 1 and Internet Router 2, and we call them route reflectors. And we just have everybody appear with these two devices. Now everybody's got full routing knowledge. Does everybody see how we created the routing for the internet and the routing for the IGP? What I'm going to do is I'm going to come off of this camera for a minute or so. I'm going to open it up for a couple minutes of questions, and then we're going to start layering in the fun. But I want to know that you guys get it. And I want to see, let me see if there's any questions, because the whole point of doing training is to get better every day. So I see Jane Ferdinand has a question. Are the accessible ISPs who have direct access to the intercontinental instead of using so many? So, Gene, I could connect to any one ISP, and every one ISP has connections to every other ISP for the most part, which means I could reach everything with just an ISP. Now, Gene, by doing this, I will always be more than one ISP hop away. So let's say I decided to use NTT Data, one of the 10 large, NTT, it's a Japanese telco, one of the best internet service providers in the world. They also own Dimension Data. Great company. I've done lots of working with them over the years. So with NTT. NTT is connected to AT&T, Verizon, you name it, Vodafone, Orange. They're connected to everybody. So if I have just a what do you call it? So Jane, if I have just, NTT, I connect to NTT, and then NTT needs to connect to everybody else. So I'll go to NTT, maybe I'll have a connection in Japan, maybe I'll come back. That's the problem when you're dealing with that. So what I want you to do is as follows. In these ultra critical latency things, what we're doing, we're adding, we're taking in full routing so we can make the absolute best decision making. So hope I answered your question. I'm going to answer another question prior to going back into the tech training, so bear with me. And any questions here are, and thank you, Jose. I love tech, I love networking, I've been doing it forever, so it's time for me and those of us that have been doing this stuff for about 30 years to raise the next generation of leaders, and that's you guys, so I am really honored and privileged to be here with you. YH, hello. In your career development program, what's the scheduled days time for the live sessions? Our live sessions are scheduled as follows. On Monday, our class is 2 to 5, and we record it in case people can't be there. On Fridays, our course is 12 to 3, and that's Eastern time. So Mondays is basically 2 p.m. Eastern, 7 p.m. Central. Fridays is 12 p.m. / 7 p.m. 5 p.m. UK time. We've chosen these times for a reason. We have an incredibly wonderful number of global students in the world. A tremendous number of our students are actually in the UK, Europe, and Africa. We've got so many wonderful students there. We've got a lot of West Indian students in the Caribbean, all over the Caribbean. We've got a tremendous number of people in outside of the Europe and Africa and the Caribbean. We've got a lot of people in Canada. We've got a tremendous number of people in Central and South America, as well as all time zones in the US, so that's how we pick these. Typically, but we record these calls so people know. In between classes, there's self-paced work where people turn in their homework assignments, and we grade them and feed them because there's lots of work. And of course, in our program, and Chris will put as much information as you want, and you can schedule to speak with us if you want about our program. We'd love to speak with you. I'm even putting in our phone number if you've got questions, which is something nobody else would be crazy enough to do on LinkedIn, on YouTube, but we do it all the time. We want you guys to get to your goals and have the best careers. So, and then we have a lab component, which is the envy of everyone. Our students come into our data center. They literally set up server virtualization. They build containers. They set up file sharing, Linux and Windows. They set up Active Directory. They build firewalls, VPN concentrators. They set up the Linux, Apache, MySQL, PHP stack. My students build an actual cloud. So when we've got actually a fair number of students in Ireland as well. Yes, absolutely. Lots of students in Ireland as well as the UK. And that's our process. Our training is about 250 hours. I hope I answered your questions. If there's more, I'll happily answer them. Otherwise, I'm going to stay tech focused. Okay, Gopal. Great tech question. Kindly explain a route reflector. So what is a route reflector? A route reflector, and I'm gonna reshare my screen so you can see it. A route reflector basically is a device that says we are willing to break the rules of non-transitive routing. So let's look at this particular example I placed here. If we just did standard IBGP pairing, router C, we've got lots of students in Mexico, actually Israel, Perez. as well as all over Central and South America. People in Colombia, people in Peru, all over. Okay, mode. Why are we using OSPF as the IGP? I will tell you, I've worked in 20 years. OSPF is almost always used as the IGP. The intermediate systems to intermediate systems routing protocol, I like it, I love it, I've worked with it. It is actually not an IP-based routing protocol at all. It's designed for CLNS routing, which we then use for IP. So the only people that are really using that intermediate systems to intermediate systems routing are internet service providers that run everything in a single area. OSPF is a better protocol as a rule, but intermediate systems to intermediate systems works great in a single flat network with no hierarchy. So when we're building large MPLS-based networks where we're signaling RSVP tunnels, then we use ISIS, our intermediate systems to intermediate systems. Welcome from Spain. Got lots of people there. I spent a lot of time in Spain. I love it. Okay, so you lost me between route reflection and IBGP. So let's go back to this. Here is non-transitive routing. Think VPC peering. C's route subnets is this. In non-transitive routing, C passes the 192.168.0.0 routing information to B. And B does not tell that information to A. So if A does not have a route to 192.168.0.0/16, can it reach it with no route? It can't. So non-transitive routing basically means when you tell me a route, I don't tell it to somebody else. And if I don't tell the route to somebody else, they can't reach it. So that's non-transitive routing. What is Cloud Hub? Or in AWS, Cloud Hub is basically saying, let's break the rules. I know I'm not supposed to do transitive routing, so let's say B was used in Cloud Hub or Transit Gateway in AWS. A route that was learned from C will be passed to B, which will then be sent to A. So basically non-transitive routing is don't tell your neighbor. Transitive routing is tell your neighbor. What is a route reflector? Well, a route reflector is, let's say B is in the hub. A route reflector says, break the rules of non-transitive routing. I'm going to let you receive the routes to everybody that's connected to me. So it's no different than Cloud Hub. If I take in a route, let's say from Rhonda, who's probably on this call, this thing in California, she sends her route to me. I give it to Joe White in Montego Bay. Joe White knows how to reach Rhonda through me. By comparison, Rhonda sends me a route. I see the route. I didn't give it to Joe. Joe's happy. Joe's doing his networking things in his country. He's doing his lab, but he can't reach Rhonda. So that's realistically speaking. iOS, one more time, let me explain non-transitive routing. You got it. You guys are going to become network experts, or at least develop your content today. Non-transitive routing means if I take a route, if I learn something from someone, I don't tell it to you. So you're one of my students. Let's say you come to me and say, I have a cloud architect interview tomorrow. I need to talk. And I say, wow, this is great news. If I don't tell Chris on my team, Io's got a cloud architect interview, set up a time for him, Chris is not going to know to set up a time with you, and we're never going to be able to speak because I can't keep track of my schedule. I have no idea what my schedule is. I just know that I teach like 8 hours a day, and I speak on phones and answer questions another 8 hours a day. That's all I know. So I don't know. So that's what transitive routing is. You tell me something, I tell someone else. Non-transitive routing is you tell me something, I tell nobody else, and therefore nothing can be done. Hope I answered your question there. Okay, Yogesh. If you wanted to set up a practice lab in your home for one of these concepts, I would suggest you do one of the following. The best way you can do this is to basically download EVENG Pro. It's about $100. We use it in our networking training programs. And with this, what you actually need to do, you're going to have to get the Cisco iOS softwares that you need. So you're going to have an account with Cisco to do these labs. And then when you have the labs, you do these things, you can set up and configure all this in a lab environment. In my days, I spent up a tremendous amount of time buying gear, but you don't have to do this. So EVENG, professional version, is the best thing. That's what we use with our students. And we've got big, bad servers to set up for our students that want to do some of this networking things. We use it all the time. Hope I answered your question. So, at this point, I think we've answered all questions. If we have not, I promise you, I will answer some more very, very, very soon. So, everyone, please let me know. If you need more, we're going to go back to the teaching and we'll go back to this. So now we've set up our network. Even with software-defined networking, latency is still a problem. We'd like to say that it's as good as MPLS, but in most cases it's not, but it's getting closer by the day. And we will definitely be talking about software-defined networking on our Friday call with me and Imran. So on Friday, we're going to have another discussion. It's going to be me, who's been a CCIE since 1999 or 2000. My friend Imran, who's also develops networking training with us, who's got 2 CCIEs and is working on his 3rd CCIE because his young student, his son who's in college, he wants him to be a CCIE, so he's doing his 3rd one just for that. So we're going to talk about the past, present, and future of networking and how it goes on Friday. I encourage you all to join. We're doing a lot of free training this week, so I hope you guys can access it. So let's get back to our network over here. So we now have our high-speed backbone connected. We've got our internet connections, and of course, we obviously need to create some kind of connectivity between these guys and everybody else, both physical connections. So we're going to just, for the part of keeping this clean and simple and elegant, just going to create a single link. Obviously, we'd be creating links from everybody to everybody, so that's why we're at it. Let's make sure we do at least one of these. And now we'll be using multiple links in a link aggregation protocol. So now let's say we have 10 gigabit Ethernet connections to the network, to the internet. Now we've got some really, really good protocol. Okay, so now let's go back and let's look at this. What does it all mean? What does it all come down to? So now you've got a good understanding of what our core routing is. Well, let's go back to the architectural requirements of this. They said they have VPNs coming in. And they told us that they need massive security, right? And we can do it again on the next stop. I'll cover that a couple more times on the next time for a break. So now let's look at this. And looking through this needs to be the following. How do we set it up? So now we've got all these connections to the internet. Didn't we say that we have a tremendous number of remote access employees? We did. We told you that we've got 1,000 private bankers that all need to VPN in. So what does this look like as 1,000 bankers that need to VPN in? Let's set this up. This is where the security architecture begins. And I'll keep this here because some people may want us to go over non-transitive routing another time, or they actually don't, and there's a delay and I can't tell. So we'll make sure we get it for those that want it. So what does this actually look like? Eric, do what you need to. You got lots of stuff going on, and we're honored and privileged to have you here, and we're here for you in any way you need. So what is it going to look like? They told you, for example, that they have no tolerance for downtime. They also told you that if they get hacked, it's catastrophic to their business. So we need real security. So let's look at really how we're going to secure this system, and then let's look at how we're going to address the VPNs. So we are going to have an external facing website. So we really want it to be good. We're probably going to do something like this. We need a content delivery network, and we need some kind of DDoS protection. So let's say we're using Akamai for this. Great content delivery network. Now behind our content delivery network DDoS protection, what are we going to do? We need to keep bad guys out. What keeps bad people out? A firewall. A firewall is this perimeter protection. You stick it around your system and it says nobody's allowed in, unless I invite them. So we stick a firewall here, block everybody. Let's look at the castle. How do we deal with the castle? Now we're not going to use proxies here. Proxies, realistically speaking, are only used to make sure in today's modern world, to make sure that you can't go to websites that you don't actually need. So for example, Augustine, if you're in Dubai, they send everything through a central proxy server to keep you from going away to certain things. Lots of countries use proxy servers. Organizations use proxy servers for the following reason. They don't want you to be downloading music all day or shopping all day, so they might push you through a proxy server like websites that basically says denied, access denied. But we're not really going to build any kind of real security with a proxy server in today's modern world. So first we're going to have a firewall. Then behind the firewall, which is like the walls around the castle, castle's got walls that are like 100 feet tall. If somebody climbs up the castle and gets past the castle, what happens? The castles typically have a moat that's filled with water and sharks and alligators. So if you fall in, you get crushed and you get eaten. Well, we need that too. What are we going to use? What's the version of a commando behind the gate? As well as the alligators? That thing's called an IDS IPS system, so we're going to need that. This intrusion detection, intrusion prevention system, we're going to see an attack and it's going to, boom, stop it right then there in its tracks. It's going to reset TCP connections, reset accesses. We're going to do this. Now, how are we going to protect our subnets? And we'll show you how to do this on 2 cloud providers today too. It's no big deal. We protect our subnets with access control lists. Now, that's part of it. Now what? Where are we going to plug our stuff in? We're going to plug our stuff into a switch. You know, servers get plugged into switches. So how do we lock this stuff down even more? Well, we do it a couple ways. First and foremost, let's do it at layer 3. Let's do it at layer 2, then we're going to add the layer 3. When we plug these servers in, we're going to put them in a VLAN. And we're going to isolate the VLANs. And what do I mean by that? We're going to group accounting people with accounting people, finance people with accounting people, computer people with computing people. So these are kind of those things. Next generation firewalls, Rob, do include some of these things, but you know, these are the modules that need to be part of the architecture, so we want everybody to understand it. A lot of the good Palo Alto new things actually do this, including some of the Cisco ones, but we want to list all the modules and services. So we separate our people, and we separate our people by, and network ACL is filled by only using the cloud. Remember, we will go to the cloud, but we need something very hard. Durage, WAF will never meet the kind of security requirements that a bank has. WAF is perfectly fine for a small company. It's a native AWS service. It's cheap. WAF is not enterprise-grade security. We need something much better. And because we're a bank, we need something a lot better. So the way we would do this is we'd use something like Akamai. Then we would use a firewall, like a next-generation firewall from Cisco or Palo Alto or Fortinet. Then we'll use access control lists on the routers to protect the subnets. Then we're going to keep our subnets separated by putting them in VLANs. Now that's not enough. We're going to make sure that if a server gets plugged in and it doesn't have the right MAC address because it's not official, it will not get open off the switchboard. So that's called 802.1x authentication. You can't do this in the cloud, but this gives you extreme security over what you would have. This in and of itself can add a 50% better security to your systems for nothing. You can't do this with the cloud. Then what we're going to do is we're going to use something called a private VLAN. What is a private VLAN? Let's say all the accounting people are in a traditional VLAN. Accounting people can talk to accounting because they're in the same VLAN. But if we use a private VLAN, individuals in the same VLAN can't even talk to each other. So if somebody's computer gets infected with a virus, guess what happens? Nobody else's does the whole time. So isn't this awesome? You're completely secure. So we're going to use private VLAN. Now, we need a lot more security that can't be done on the cloud. We're going to only make sure that subnets have routing information. So let's go back to that transitive routing, because I know Io had a question on it. And then we're going to bring it back to here. In transitive routing, basically, what makes transitive routing is if C tells A, if C were to tell B its routes, and then B were to tell router A C's routes, all the communication could occur. Now let's go back to this non-transitive routing concept. If C tells B its routes, but B doesn't tell A can't reach it. It doesn't have a path. So now let's think about security. I want to drive to Chris's house in the Tampa region. I don't have a road. How am I going to get there? Well, it's going to be awfully hard. Sure, I can, run across the swamp in Florida, chop down trees with a machete on the way to Chris's house, fight alligators, crocodiles, snakes, spiders, along the way. But it's going to be hard. And it's going to take me more than a day to do that walking. So by doing this, by limiting routing information, you pretty much, make it hard for people to see we're going to limit routes. Now, that's not enough. This is massive security, about double that you can get on the cloud, but it's still not enough. So how do we make it better? Well, we're going to put what's called a host-based firewall. It's going to block stuff coming in. On the cloud, that's the equivalent of a security group, but maybe this is a little stronger. Then we're going to add some anti-malware. Then if you ever do like a netstat on your computer, you're going to notice all the listening on all these ports. Listen, listen, listen. Why is it listening? It's open and available for hacking on these ports. Wow, this is not good. So let's start looking at some of these things. Open for hacking. We don't want to be hacked. Close those ports down. And how do you do that? You disable any unnecessary services. You think that's enough? Of course it's not. You got to patch the stuff too. You don't want any security vulnerabilities, so patch the stuff. Is that enough? Not really. Part of the security architecture that goes with something like this. What about our storage? Let's say we've got some storage. What are we going to do with our storage? Now, I want you all to truly understand encryption when it pertains to storage. Does encryption solve the problem if somebody hacks into you, getting the information? No. What does encryption do? You come into my house, you steal my RAID array that's sitting on my desk. If you steal my RAID array and my data is encrypted, you can't do anything with it. So all encryption does means that if somebody breaks into your data center and steals your stuff, they can't use it for it. So of course, we're going to do storage encryption. Now, I'm not a good speller, so if I make some spelling errors, please bear with me. So we're going to store our encryption. Now, what about users accessing the system? Now, let's be fair. I view IAM as like 5% of what's necessary to actually do security. Why? If they can't get in, 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 and can't really attack their systems because they're all disabled, they're there. So if you're 5,000 miles away and you're trying to charge into my house and knock on my door, and you can't get to my door, well, you're not attacking me. So what is IAM? IAM, or Identity and Access Management, determines who are you, what you're allowed to do, and then locking it. So it's part of it. So let's say you break through all of my layers of security, which you're probably not going to do, and if you do, it's going to cost you millions of dollars to do it. It's not going to be easy. So let's say you do. Now, you're at my front door. This is where IAM comes in. Who are you and what are you allowed to do? So IAM, I view, as the last possible thing as part of your security architecture. Why? Because I view it as the least effective part of the whole process. It's part of it, but it's the least effective. All this other stuff is, imagine, you can't get to my house. Does it matter if you even have permissions in my house? Of course not. You can't get there, so block it. So this is how you do this. Now, I told you that we're going to have people coming into the systems. We've got 1,000 people that have to VPN in. How are they going to get in? We're going to have to put them somewhere. We're going to have to create something called the demilitarized zone. And what is a demilitarized zone? A demilitarized zone is a place where we've got a partial policy that basically allows one thing, say a web server. So let's say our VPN concentrator is here. And I would never use an SSH VPN. It's not strong enough. We use IPsec VPNs. Those SSH VPNs that were very convenient and fun to do, those SSH, SSL VPNs, for the most part, they died about 10 years ago due to lack of security, which is why if you really care, you will never, ever have anything like a Bastion host on your system. Talk about a way to make your systems 1,000 times more hackable. You would never do this in a good environment. So let's talk about this. You're going to create a demilitarized zone. So basically speaking, anybody that comes into our firewall, they're going to allow access to a single port or protocol coming in here. Let's just say, for example, we are using an SSH-based VPN. We would allow port 22 to come into the firewall and go out a specific subnet on the firewall. Now then, that would be firewalled off or blocked from remaining in the system. So that's where we're going to put our web servers in the demilitarized zone. But guess what? We're going to be doing the same thing for our VPN concentrator. They're going to come in, pass through the firewall, hit our VPN concentrators, and be placed behind the firewalls onto our corporate network with the corporate IP address. I hope that makes sense. So what have we done here so far? We've set up high-performance internet connections, real high-performance internet connections. We've set up a security environment that's high security. We've shown you transitive routing versus non-transitive routing. And we've shown you the core access and distribution of the network. Now, that's part of it. Now, what about these servers? We've got lots and lots of servers. So let's build out our environment, and then let's start considering the cloud. So what kind of servers did we tell you we had? We told you we have machine learning servers and trading servers all inside of our data center. So let's realistically look about what these servers are. Let's really knock it out. Oops. Let's look at the server architecture. So we have 1,000 GPU servers doing their thing. And what do these servers look like? Philip Hudson, can this data center be replicated to the cloud? Well, we're going to build a disaster recovery site on the cloud. And we're going to replicate this as much as possible on the cloud. I'm going to tell you this. The cloud cannot do with any way near the performance that we're going to do in the data center. So if we go to the cloud and we can make it possible, on backup, the organization, if they ran on the cloud, would lose billions of dollars per year. They told you that for every nanosecond, or for every millisecond, they save $500 million. Stick this stuff on the cloud, you've got 5 milliseconds latency minimum over a direct connection, and that means $2.5 billion of loss per year. So can you do this on the cloud? Yes. Can you do super high performance in the cloud? No. Can you do scalability on the cloud? Absolutely. Do you have agility on the cloud? Yes. Is the cloud the perfect disaster recovery environment for this? The answer is yes. And we're going to show you how to build this on 2 clouds because, like I said, this is a customer where money does not matter. All that matters is performance. They're funded by a billionaire. They've got billions of dollars to spend on tech. I worked on this stuff my entire life. So let's look at it. With these 1,000 servers, what do they look like? Well, we've got, let's look at them. We've got, each one of them has 6 NVIDIA Quadro A6000, which is an extremely high performance GPU. Each one of these is about $7,000 or $8,000. We're going to stick 6 of them in a box. It might cost you $7,000 a month to run one of these GPUs in the cloud. We're going to buy them for about $7,000 each. So give you a perspective of when is it cost effective on the cloud versus not. For this organization, around 100 of these things, they need to own it. It's going to be much cheaper and the performance is going to be better. And let's say each one of these systems, because when you're dealing with systems like this, all the compute, we're not using a VPN, no VPN for something like this. Oh, why are we using a VPN? Okay, so we have sales reps, as I mentioned in the beginning of this, financial advisors, and they VPN to basically get access to the system and their clients' private information. That's the only place we use a VPN, but we don't use VPNs for everything else. The reason we're using VPNs, Mega, is our sales reps who sell our financial products travel constantly. And because they travel constantly, it's not possible to set up direct connections to them in their locations. So why do we need these big servers with these 128 cores and 4 terabytes of RAM when all the computing is done on the GPUs? What goes on, and when we start dealing with these big high performance servers, the goal is to get to the CPU. So the CPU is basically the controller of all the things that goes on in your system, in your architecture. And when you're dealing with these big systems, they have more lanes to your PCIe cards, which is where your GPUs are housed. They also have more memory bandwidth. So the reason we use massive servers when all the computing is actually done on the GPUs is we need that. If we don't have that, we are not in a position to basically deal with, let the GPUs do their things. And we don't want system bottlenecks, so that's what we're doing. So now that's what these look. Now let's look at, we also have 100 servers to process trades. And we've got to get these things in the lowest latency environment. So this is not going to be a standard rack, a standard environment. So we're going to have to do extreme things on the network side to get this to happen. So now let's look at our next. We've got 100 servers that process trades. So these servers all, so 100, let's make sure we do that. 1,000 trading servers. So in these things, let's say they're basic servers with 128 cores. It's called an AMD EPYC CPUs. They're the best out there right now, and all these organizations are using it. Let's say they have 4 terabytes of DRAM, and let's say they all have 8 times 8 terabyte NVMe drives in RAID 0, and they've got a backup of these things. So for RAID 10, backup 8x8. We got a lot of architecture work to do on these things too. I'm just mapping it out. So RAID 10 is what we've got here. Now, when you're dealing with something like this, I want you to put it into context. A high-performance EBS volume at maximum speed is 64,000 IOPS. There's a new special performance provision IOPS that can get you to 250,000 IOPS. Here, what we're doing was at least 5 million IOPS, maybe 10. So, can you get that on the cloud? Well, if you're using standard EBS volume, meaning the high-performance provision ops, you're going to need 64,000 K times 100 to even get close to what we're dealing with here. So you'd have to put 100 of these volumes or 1,000 of these volumes in RAID 0, which would be totally a disaster. It might cost you a few $1,000,000 a month. And in addition to that, your failover would be a problem because it's just not reliable to do that. So we can't get this kind of disperformance in the cloud. The only way we can is to use instant storage on these servers because the cloud servers are pretty much the same. The problem with using instant storage is as follows. When you use instant storage, guess what? When you reboot it, you lose everything. So totally not an option for an environment like this. And then we've also got web servers. So our GPU servers and all these other servers, we're going to be load balancing. To use more than one server, what kind of a device do you guys need? A load balancer, right? You think you can use an application load balancer to load balance 100 servers with 128 cores and 4 terabytes of DRAM, where each one has 5 million IOPS, or you think you need a network load balancer because you need speed or performance? Comment on the type of load balancer you want in the chat box so I know you're here. Leo, good job. You're not doing that on an application load balancer. What would you use instead, Leo? Let me know that you guys are here. Leo, good job. Network load balancer. Exactly. High performance training means a network load balancer. Okay, you guys are here. You're awake, you're alert, you're oriented. Oh, by the way, I'm told that I'm supposed to ask if you're enjoying this content to please leave a like or subscribe to the channel and hit the bell to be informed of new things. I'm not Mr. YouTube. I love to instruct people, but I do have to try and run this channel. So good, you guys are getting it. We're using a network load balancer. Perfect, perfect, perfect. Because we need that level of performance that is not achievable anywhere else. That is why we're using network load balancers. So, now, let's realistically think about this. Load balancers, load balancers, load balancers. Now, while we're at it, let's architect a website. But what do we need to do to make this stuff work? How do we minimize the latency of these servers? Does anybody have an idea how we make these systems extremely low latency? In addition to using network load balancers and using the fastest servers in the world, what do you guys think we should do to these things to make them higher availability, high performance, and lower latency? Any ideas on the network side? Okay. What kind of network card should we put in these systems to make sure that they have the highest performance bandwidth? We're using fast Ethernet, 100 megs, gigabit Ethernet, a gigabit per 10 gigabit or 100 gigabit Ethernet. What do you think we need here? What kind of network performance do you think we need? At least 100 gigabit, right? So, Augustine, what we're going to do here is we are going to put dual 100 gigabit network cards inside of each server and connect them to 2 different switches to make sure that they don't fail. I want you guys to think of something else. Every time a packet hits a switch or a router, there's the delay. It has to be processed. Packet comes into a router. The router does a lookup. And we can't use a CDN for this kind of stuff. My God, that's only for websites. So packet comes in and hits the router. The router does a lookup in its routing table. That's okay, Ryan. We'll teach you. It does look up a routing table, and then it sends it out the right switch port or port. And when you do that, that's how the forwarding occurs. Now, every time it goes through a router, it adds latency. And remember, a millisecond of latency costs $500 million per year. So we're going to use multiple redundant 100 gig network cards. Now, do you think cable length matters? What happens if we run a cable for a mile? The speed of light is 186,000 miles an hour per second, which is pretty darn fast over a fiber optic connection. But distance equals latency. Do you think it might make sense to put all these servers in one rack, or right next to each other, plug them all into the same high performance switches? consolidating them so they're super close to each other. And in AWS, they would call it like a cluster placement group. But this is more than that. What if you put all these devices in these, $500,000 ultra high performance switches? I mean, the best of the best. And then you put them all close to each other and you use the shortest fiber optic cables possible. Do you see how that would reduce latency a little bit? You guys let me know that you hear it. And if you need to ask some questions now, go ahead, ask some questions. I'm happy to take a break. We're getting into some deeply advanced concepts here. So Augustine, the elastic fabric adapter is kind of a silly thing in my mind. The elastic fabric adapter is basically another driver to use in your virtual machine to give it better performance. It's a virtual driver. That won't even come close to what we're talking about here. We're talking about a virtualized instance, a virtual driver, and a virtual computer. Just that is going to add, a quarter of a millisecond of latency that we don't want here. Just that. So we can't use something like that. Now, there's something called single root I/O virtualization. I didn't make up this term. And what is single root I/O virtualization? It's as follows. You've got your virtual machine, and inside your virtual machine, you literally pass through a hardware directly into your virtual machine. So instead of your virtual machine, like your EC2 instance, for example, having a logical network card, like an elastic fabric adapter, you literally physically push the hardware into the virtual machine. So it's not a hypervisor-based card, it's an actual card. So that's single root I/O virtualization, otherwise known as high-performance networking. That, realistically speaking, what they're doing, the high-performance networking single root I/O virtualization is one step beneath what we're doing here, but very close. This is direct physical hardware, access to the hardware, access to the CPU, access to the PCI cards, fastest thing possible. So you can do good on the cloud, but you can never, never, never make it anywhere near as good. We don't want to make the NIC virtual aware with this environment. We're going to run everything on bare metal. Why are we not running KVM or VMware ESXi for systems like this? That hypervisor adds about 10% performance hit, which is why on the cloud, at best case scenario, you're always going to be 10% slower, best case scenario, because of the hypervisors in the same system. So we're running all these on bare metal because we need speed. What else are we going to do on these bare metal servers? How do we optimize it further? How do we shave some networking time out? Well, we take a custom Linux instance, like Intel Clear Linux, and then we start stripping out unnecessary services, and we make our Linux the lightest way possible and saving maybe another 2% resources. This is what's going on. Well, Harry, sure, we'll talk about how we can find easily in our environment how to figure out what's going on. In our environment, we've already got so much security policy, we're going to know exactly when someone's breached our security. We'll go back to that security architecture in a minute because you probably weren't here when we actually built the security. So if that's the case, we'll work through it. But we'll go there back in a minute or two. So what we're going to do here, we're going to stick our servers in, we're going to plug them into the fastest switches in the world. We're going to plug them in as close as possible. We're going to shorten our cables. We're going to do all this. And what are we going to do? Instead of going directly to the access part of the network, plugging into the distribution, we're probably going to take this special high-performance computing cluster, put it in a massive switch, and send it like a distribution layer switch, and feed that directly into the core. Because we need speed, 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 speed. So that's what we're going to do on the networking side. Now, for our GPU servers, it's going to be the same thing. We're going to put them as close as possible together. Now, when we do this, we're going to have to make these redundant. Now, it sounds crazy. So let's say we plug into two switches. A switch on one part of the network and a switch on another. Anytime you put your computing power close to each other, okay, there is no, so Mandahar, I'll get to some questions in a second, because you wouldn't use single root I/O virtualization for bare metal. You wouldn't have to. So let's kind of walk through this for a second. So let's go back to where we're at. So for these systems, we're going to plug them directly in. But imagine this. Imagine everything you have, all these servers are plugged into a switch. Now, is that a problem? Yeah, sure is. What happens if something fails with the switch? What happened to the cells of the cable in the rack? So we're going to be redundant these. We're going to be running redundant high-performance clusters. So instead of having 100 trading servers, we're going to have 200. 1 is none, 2 is 1, and 3 is better than 2. We're going to have 2,000 GPU servers. We need to know this is going to work. If a single one of these things fails, or it fails into one of these switches that they're plugged into, we're going to have another one take over immediately based on some routing policies that we've done. So we're going to run simultaneous high-performance compute clusters all close together. So let me deal with Mandahar's questions, and then we're going to get back into the fun architecture. So you asked, what is SRIOV for bare metal? Well, here is what bare metal is. You buy a server from Dell. You install the operating system in your applications. That's bare metal. The operating system talks directly with your hardware. There's no virtualized hardware. So that's why when you deal, for example, with virtualized machines, their performance is nowhere near as good as the real thing, because you're not dealing with real hardware. You set up VMware ESXi or KVM or QEMU on the server, that adds a thin hypervisor. That then gives you logical, not physical, logical cards, a fake Intel VMware kind of network adapter, a fake GPU, a fake hard drive. All of it's fake. It's virtualized. So what single root I/O is, instead of having a fake hard drive or a fake network card in your virtual machine, in the virtual machine you pass through directly in there. So it's putting a virtual network card in there. I don't know if I have the ability to share my screen of a window where I can log into a VMware ESXi server of mine. So I'll do another one where I'll host a VMware ESXi demo, and we'll show you, if you desire, how do you set up traditional virtual machines, how do you network them together in VMware ESXi, and maybe how these things work together. And then we can show you how to create single root I/O virtualization. Single root I/O virtualization is basically what you do when you're using virtualization and you need to get near native-like performance. So if you're native, you don't need something to get you almost as good as native. If you're native, you're already native. The single root I/O is a workaround to the poor performance of the virtual machines in the cloud. How common is it to use single root I/O virtualization in the cloud? Pretty much everything I'm going to do is going to use single root I/O virtualization. But I only get put in these kind of weird, particular, crazy environments that are big like this. So in my world, it's a daily thing. For regular clients that are basically just using the cloud for a web app and database tier, something small, it's not a problem. For a big, massive deployment like this, it's used everywhere. So it depends on what you're doing. Let me make sure that I understand where everybody's headed from here. If you guys want us to basically teach you server virtualization and walk you through setting up and pushing through physical cards into server virtualization, type Cloud Architect in the box below, and then we know you guys are paying attention and you desire it. So let us know. If we get above 50 Cloud Architects, we'll demonstrate virtualization. We'll do a free live stream maybe next week or the week after that. We'll teach you guys how to set this stuff up. Physically do it if you want. But only if I know you're there. There's 80 people on the call, so I need to know how many people are there. We determine based upon feedback from the customers what we should produce. Or we produce content because we taught a class and thought our students needed to know more. So we make, that's how we make our weekly YouTube videos. So just to let you know. So hope I answered your question there. Leo, you want it? If we get enough other people with you, although Leo, I know you get access to the videos that teach you how, but I'm happy to do a live demo if you guys want it, if I get enough Cloud Architects typed in the box below. Okay, Yogesh, are you a yogi like me? I've been teaching yoga for 15 years, something I absolutely love. I'm seeing enough Cloud Architects. Let me know, send me some more Cloud Architects, and if you guys want it, we will teach server virtualization in a live stream. Always happy to coach people. Jeannie, wonderful. Robert, wonderful. Gopal, wonderful. I need about 20 more Cloud Architects, and if that's the case, we'll be teaching it next week. Or the week after that. I've got a pretty crazy schedule of live streams with some people coming up in the next week or two. If you guys are enjoying the live streams, we're going to do a lot more of them. As it turned out, my video editor, Manuel, who we love, just had a baby. So we're not making any videos this week, which is pretty hard for me because I love making my YouTube videos. And as it turned out, we blew up our channel, really hit 10,000 people, which we started very recently, and we're excited about it. So we wanted to give you guys live training every day. And yes, Mandahar, there is a video on how to set up a hypervisor on bare metal in our training course. But we might make it a little prettier for you. We may actually use a video capture card, and we may literally teach the entire course one by one, set up a Windows VM with you, set up some Linux VMs with you, maybe set up some cool stuff. We want you guys to have a great time. So I've got enough cloud architects in the window. We will do a live server virtualization demo. So you guys asked, we'll do it. We want you guys happy, 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 and learning as much as possible. So now let's look at this website. How do we architect this website? And so we've looked at what our security pattern, and for the person that asked the security question, how are we going to know if someone got in? Well, first, they're probably not going to get in because they're going to be blocked by the DDoS protection. Actually, we do have one video on our webpage, Chris, about setting up server virtualization, but it doesn't look beautiful. Thank you so much, Ryan. And we like the forever loop of cloud architect. That's everything we do is building cloud architects and network architects. So as much as possible, we love it. So to have it here. So the cloud architect loop is all that we want to see. So now let's go back and have some more fun with this, everyone. So let's now look. The question was asked, how are we going to know if we're hacked? Well, probably not going to pick it up our content delivery network. Our firewalls will send us about 18 million alerts. They've got an integrated IDS, IPS system, and they will stop stuff. And they're going to send syslog messages. We're going to be notified. We're going to be getting text messages, emails. It's going to drive us nuts. Then they're going to hit the ACLs on our router. And you know what? We might set up some kind of logging functions, again, to get more syslog messages when something's blocked by our ACL policy. And by doing that, we can start sensing things. We can start looking at our logs. No, we're going to get more logs from our VLANs. We're going to get more logs if someone tries to plug in a computer and their MAC addresses and authentication. We're going to get logs, logs, logs. Now, every server we have has host-based firewalls, anti-malware protection, and IDS, IPS systems working on it. Again, this stuff is going to let us know. So our servers are going to be running the most up-to-date security work, and they're going to constantly tell us when something's going wrong. So you may not have been here when you asked that question. How are we going to know? That's how we're going to know. And also, Mr. Karuthanani, we're going to be running checksums on our data to make sure nothing's filed, but we'll be looking at hashing algorithms that all use a one-way hash. So I want you to truly understand exactly how far we go. We go pretty darn far to make sure that we get our students to their goals. And that's how but that's also how you would design these high security environments. People think you get information in the cloud. You get about 10 times more outside the cloud than on the cloud. Cloud's great, but you know, what are we doing? Why are we inviting the cloud here? We need the best performance, and we can't get this greater performance on the cloud. But we're going to use the cloud for disaster recovery. So now let's go build our website. And we're going to build this interactively because this stuff is pretty easy. So now let's build the website, and then we're going to connect it to 2 cloud providers, and we're going to have to pick out the services for our disaster recovery on the cloud. So that's where the fun begins. So let's just do this. Apologies, my phone literally runs 24 hours a day, 7 days a week. Today it's my turn to hold the phone. Another day Chris may have the phone, so somebody always answers the phone in our organization, except when we're teaching. So now let's look at this. What does the website look like? How do we map this stuff out? So let's look at this high performance website here. Let's take it from point A to point B. We have, what were the numbers we gave you in the beginning? 100 web servers that all have 128 cores and 4 terabytes of RAM. What is that device we need to use to load share across these 100 web servers? Does anybody want to tell me that? What do we need to use? What do we use to load share across servers? 100 web servers? What do we need? What kind of network device? It's not really a network device, but how do we load share across all these servers? You guys want to tell me? We need a load balancer. Why can't we use an application load balancer for these 100 servers that have 128 cores and 4 terabytes of RAM? It has to be a network load balancer. Why can't we use an application load balancer? What do we know about application load balancers? They're highly intelligent. What happens when you make an intelligent device? Is it fast or slow? If it has to do 10 times the computation. It's slow. Application load balancers are pathetically slow. Application load balancers are good for your 2-core server. They're good for your Linux. They're good for your microservice. But you can't use a network load balancer when you've got, an application load balancer for high performance needs. Network load balancers are for high performance. Application load balancers when you need low performance but intelligence. Routing between parts of the path on the TCP header. Application load balancer. Routing between microservices. Load balancer. You need performance. You can't use an application load balancer. Good for routing from containers. Not good for big high performance environments. So that's why we're going to use network load balancer. So we need a network load balancer. Now let's behind the network load balance put our servers. And what's this going to look like? We've got our servers, web. We're going to map this out and do lots of cool stuff. We're going to have 128 cores here. What else are we going to have? 4 terabytes of DRAM. Now guess what? We have 100 app servers. The app servers are the same size as these web servers. So we need another, what do you call it? Another network load balancer, right? Okay, great. Okay. So now, what about our database servers? We told you we need 50 database servers. And these 50 database servers that we have all have 128 cores. 128 cores. We told you that they all have 4 terabytes of DRAM. We told you that they have 8 times 8 TB NVMe. And then they've got a backup 8 times 8 TB NVMe RAID 10. So that gives us 64 terabytes of capacity in every database server and about 6 million IOPS for each one. So do we have any disk or constraints or performance with this at all? No. We've got nothing. So let's look at the rest of the requirements. They told us they can't let a worm or virus cause problems in this system. What does that mean? Okay, let's think about this logically. I've got a massive server with a 100 gigabit network card, and it gets infected with a worm. A worm is a type of malware that spreads. And my server now sends at 100 gigabit per second worm traffic to the network. And I've got 10 servers and they'll get worm traffic on the network. Is that going to fill up my network, everyone? Like, with that half a terabit per second of worm traffic? Trust me, I've seen it happen. I advised one of the world's largest banks in the world that when they were running gigabit Ethernet to the desktop, they must run a QoS policy on it. I said, you've got a new IP voice phone system. Here's what's going to happen. You're going to have worm or virus. It's going to send traffic over your gigabit Ethernet. It's going to send so much traffic, you won't even be able to place a phone call when your systems are down. You know what they said? Not possible. Gigabit's full. A month later, do you know what happened when the company got a worm? This big global bank? Every one of their network connections was 100% full with worm traffic. So how do we fix this? What do we do? How do we further protect ourselves? And you can't do this on the cloud. Remember, the cloud is a much less secure, much lower performance environment, but it still has things. Let's take this environment, let's look at it holistically from a network perspective. So let's say you've got your server, and let's say you've got your switch / router. We're talking about layer 3 switches. Let's call it a layer 3 switch. Now you got your user. Let's say you got your user on this side. If got a 100 gig connection. And let's in this case say the user's infected, because our servers are much more secure. So we've got a link. If our server is completely infected with a worm, our user will send, let's say we've got 100 gigs. Network ACL is not going to be good enough for this. We're going to need much more. And what a network ACL is good for, as a rule, is basically saying only this is allowed to talk to this. But you can't stick it everywhere. So now we've got to do something better. We've got to make sure that real traffic actually goes. So typically speaking, what we do is we set up what's called a QoS policy. And here's what the QoS policy is going to look like. Let's say you got to switch to a switch. We're going to set up a QoS or queuing policy. What we're going to do first is we're going to prioritize critical traffic. And typically what you prioritize first is voice and video. Then what you're going to do is you're going to add another link. And that next queue is basically going to say critical data. And then you're going to set up another queue that's going to be for normal data, like FTP kind of data or SFTP. So then we'll say normal data. And then we're going to add one more, and we're going to call this unknown or unimportant data or unknown data. Unknown data. So we prioritize the most important, then we prioritize the critical, then we prioritize the normal, and then everything else is deprioritized. So system gets infected with a worm. First the voice gets through, then the data gets through, then the normal data gets through, and then the unknown data gets through. Can we do more than this? Sure. We can even create a policy that says, if we desire, rate limit all unknown data at 50 megabit per second. So when my students VPN into my home, which is one of my data centers, when my students VPN into my home, I stick them into a demilitarized zone on a specific VLAN. I limit, literally speaking, the traffic to the sub. I limit the traffic that the DMZ can have to 100 megabit a second. Why do I do that? I've got all these other things going on. If one of my students sets up a Kali Linux machine, which my security students do all the time, and they generate crazy traffic, first it's firewalled off from me, and not only is it firewalled off from me, I can't let them take down my entire internet connection, or it'll take down all my students. So I rate limit. So we're going to also rate limit here. So these are kind of the things that you kind of do. So Struchik, I will tell you, regarding the CCP, and then we'll go back to this, we strongly advise people against ever taking the cloud practitioner exam. We strongly advise people to, literally speaking, start with the AWS Certified Solution Architect Associate and go straight to the professional for people looking at architectures. The reason we always avoid the cloud practitioner is as follows. It's nearly impossible for me to get someone a job with the cloud practitioner. The cloud practitioner exam is almost as challenging as the Certified Solution Architect Associate. And we really know that minimum entry level to practice is the Certified Solution Architect Professional. That's kind of like beginner's entry level. We build cloud architects for more than just certification providers, and then we get our people hired so we know what it takes. So I recommend, if possible, go straight to the Certified Solution Architect, save yourself 2 months of training, and then go straight to the professional. Or if you've done the Certified Cloud Practitioner, go straight to the Certified Solution Architect Professional. Time is money. The average cloud architect earns $600 per day. Every day that you're focused on training something that's not getting into your goal is costing you a fortune, $12,000 a month on average. So we recommend against the CCP. Please subscribe. We've got a Certified Solution Architect Associate, Professional, and Advanced Networking course, completely free, and bugs to help you get through them. So Love to have you here, but I just want to make you get to your goals first. I want you hired as fast as possible. Please come to the webinar tomorrow. That's what Johnson said. We want to help you get to your best career as fast as possible. So now let's go back to this situation. You see how we caused some rate limiting. So you can't do any of this on the cloud. So when you're on the cloud, and I love the cloud, realize you're losing control. All of it. Realize you're losing performance dramatically. But you get agility, auto-scaling. So there's lots of reasons to be on the cloud, but as an architect, you need to know what needs to stay in the data center and what needs to go to the cloud. None of this stuff is going to be great in the data center. I mean, in the cloud. It's all greater, better in the data center. But that doesn't mean we shouldn't use the cloud. Thank you so much, Megha. I'm really looking forward to the days where we have a bigger YouTube presence. I never thought I'd be on social media, but I got to tell you, communicating with the widest audience that I have get to speak almost daily to people in the Caribbean and Africa and India and Asia and Central and South America, Europe, England. Never been a better experience in the world, so I absolutely love it. So thank you so much. So now you guys kind of know what it looks like. So we basically, let's go through the requirements. They can't let a worm and their virus, take down everything. We just talked about that. They want to have a super high performance website. Well, we've got 10 gig links to the internet, and every one of our links are running BGP. So we have, literally speaking, the most direct path to everybody on the internet. We met that requirement. They are extremely concerned about disaster recovery. And what does that mean? Well, we only have a data center, guys. Do you see a problem with regards to disaster recovery if the data center goes down? And Walter Williams, while I'm waiting for you guys to see if there's a problem to only have a single data center, and answer, if you think it's okay to have a single data center, type single data center. If you think it's not okay to have a single data center, type cloud networking, so I know that you're here live. And while you're doing that, how accurate is our practice test for the professional? Walter Williams, we are not in the practice test business. We use that as a baseline exam, meaning if you can take that exam cold and score 95%, you're good to go for the exam. But it's not like a big practice exam with thousands of things. It's a screener exam. So I will say there are good practice exams on there. Some of the practice exams on there are so good and accurate that they literally will enable you to pass the exam without knowing literally anything about it. But that's the case. So we've got a single data center. Not the best thing here. Got no disaster recovery. We got the world's fastest, most technologically optimized bank in the world. No disaster recovery. Okay, this is not good. So what do we do? How do we make this work? How do we promote a disaster recovery environment that's going to be fast? So now let's talk about how do we do this? And what's it mapping out? So let's take these requirements. The CEO of this company, the financier of this company, is a billionaire, multi-billionaire. The CEO, the person that's funding this, has a lot of people don't like me. He said, I contribute to a lot of charities that one side of the political world does not like. And he said, I want to make sure that nobody locks us in, that nobody can kick us out of their systems. He said, it happened to a friend of mine that started a business on a cloud provider. They were kicked out. It's extremely concerning to us. We want to know that we've got multiple clouds, that we can never be taken down by a single cloud provider should anything matter. So let's do this. So what does that mean? It means no cloud native, because we don't want to change our code and we don't want vendor lock-in. So we don't want cloud native. So it means whatever we have. Now the other requirements are the environments must be able to survive a data center failure within 5 minutes. How do we take this data center, get it to completely be replicated to the cloud within 5 minutes of downtime? So what could we do? How do we arrange this? What should we do? Well, we've mapped out a lot of stuff so far. We've mapped out our data center network. Good. We've mapped out what our IGPs and our EGPs look like. We've mapped out our security protocol. kind of mapped out our fancy servers here. Now we've mapped out our website. We've talked about QoS. So now let's look at it. Now let's think about what an architecture here would be kind of cool to do. So what if we have our data center? Let's call this our ultra high performance, and that's exactly what this is. Okay, so now let's say that there's a massive earthquake which causes a fire to burn our data center down. You know, our fire suppression systems, our redundant generators, our redundant power, all this stuff doesn't work. We need something else. So what do? We connect to the cloud. How many clouds? They're concerned. Why are they so concerned? They're concerned about their friend that got kicked off of a cloud provider. Now, who probably provides the highest performance compute infrastructure right now? It's probably AWS. Who is the most flexible regarding not caring about your business background? That's probably Azure. So what do you do when you're providing the world's most high performance trading system and you connect to two clouds? This is pretty normal stuff. So let's say this is AWS, and let's say this is Azure. We're going to use both. And we're going to design the systems on both clouds after we're done this. So let's look at this. So what kind of a network connection do we need for low latency to AWS? Remember, we're literally running 400 gig links in our systems in a link aggregation group for performance. What's the minimum kind of connection you think we need to the cloud? Or the best connection we can get to the cloud? We can get a 100 gig direct connection to the cloud. Now, AWS does support link aggregation groups, but they don't enable us to get more than 100 gigs when we connect to a link aggregation group. So now we got some trickiness. How do we get good performance to the cloud if we can't load share on a link aggregation group? Let's say we do a direct connection at 100 gigs, another 100 gig direct connection, another 100 gig direct connection, and another 100 connection. How can I load share across these links without a link aggregation group, without getting out of order packets? What could I possibly do? For Cisco, obviously we could have set up another direct connection. A total backup data center. But in this environment, I wanted to give some networking and cloud networking together. And the cloud is a cheap way to provide this kind of redundancy. Well, in some ways, yes, and in some ways, no. What do I need to do to load share across these links? If I set up by standard, are we going to load share? And if we do, are we going to get out of order packets? The answer is yes. How can we load share across these links? What do we need? What enables the routers on both ends to be intelligent to say, for subnet 1, use the top link. For subnet 2, use the next link. For subnet 3, use the next link. For subnet 4, use the next link. If any of these things fail, have the other links take over. What do we need? What's that thing we need, that magical thing that determines our best path to the destination and enables us to load share? What's that called? Type it in the chat box. How do we load share across all these fun direct connections? Somebody tell me. We need a routing protocol. We can't use a link aggregation group, Walter Williams, for the following reason. AWS does not let you get above 100 gigs per second in a link aggregation group. So if we bundle our 4 100s together, we're still stuck at 100. But if we use BGP, like Francisco said, we can place subnet 1 on one link, subnet 2 on another link, subnet 3 on another link, and subnet 4. And if you guys want, we will set up a BGP policy for that as soon as we design the rest of that stuff, and it's going to be fun. So that's how we do it. That's how we create high-performance networking to the cloud. Now, guess what? Azure's a backup. We're going to use Azure as a backup to our other cloud. Okay, so Walter Williams, spanning tree protocols layer 2. and really slow. We're not going to be using spanning tree when we connect to these things. VRP, or Virtual Router Redundancy Protocol, is basically how you point your PC to a logical router and it can choose each one as a default gateway. In this, we need an actual routing protocol, and that routing protocol is actually BGP. So John Oho, great job. So we're going to do the same thing with Azure. I'm going to create a couple 100 gig connect direct connections. Now, we need one of these devices to come up within 5 minutes. And we need the other one, the backup, can be 45 minutes. And the organization, for backup purposes, only wants to back up the website, nothing else. They're not going to back up the trading system because they feel they're good and solid having that on AWS, and they're super high availability, super high performance data center. So the only thing that's actually going to be backed up at all in Azure is just going to be the website. So now let's think about this, and then we're going to set up the BGP policy, and I'm going to teach you how to traffic engineer it. So we need something a lot more than ExpressRoute. We need BGP for this kind of stuff. So now let's look at this. Now let's take these servers that we have, and I'm going to need your help here, guys. I'm just the CEO today. I'm just a teacher today. I need you guys to help me figure out what the cloud services are for the AWS and the Azure environment, because we're going to design it then, and then we're going to have fun with some BGP tuning, because this is a networking party and networking is just cool. So now let's start talking about what we need to do here. Let's have some fun. So now let's translate these requirements. So we're going to be using AWS. So this is the data center. Now let's build our backup data center in the cloud. What do we need, architecturally speaking? By the way, this is why I say for you guys, architects, this is architecture work. It's design. No configuration, no coding, just design. So now let's say we want to use a content delivery network with AWS. Anybody know what that would be called? In John Oho, we could use BGP multipath, but we get out of order packets that way, or potentially do, especially if we're going to have one link with Verizon and another link with AT&T. So we're going to actually be very specific, and I will set up and design a BGP policy with you guys today after we pick out the cloud services, and we will have fun with it. So what is the Amazon branded content delivery network? CloudFront. Great job, Francisco. So this is now on AWS. What are we going to do? We're going to swap it out. We're going to replicate 100% of this. So we're going to call this AWS. Good job, guys. CloudFront. Now, I told you we need a really high performance, high security firewall on AWS. We need something that's going to be much more sophisticated than something silly like WAF. We need enterprise grade security. What are we going to use? Where are we going to get a Palo Alto or a Cisco firewall to go work in our cloud in AWS? Where's that place that we go where we get a specialty appliance and we put that appliance directly on an EC2 instance, and then we've got enterprise grade security? Where do we go? What's that store called? Marketplace. Leo, great job. So we're going to get a next generation firewall from the marketplace. Now everyone, assuming it's not part of our next generation firewall, where do we get the IDS IPS systems? Shield is DDoS, and we would attach Shield, which is totally fine. Suba, great job. We'll attach that to like the CDN at the front, or a load balancer or something like that. But so let's put some Shield here too. Good job, Suba. Where do we get this, Leo? You told me. Okay, from the marketplace. That's exactly where we get the IDS IPS system. Now let's go pick out our services, everyone. An access control list on a router keeps traffic in and out of subnets. Is there an AWS service that does the same thing? And if so, what's it called? Tell me the name of that service and what's it called. Okay, so what is an ACL equivalent in AWS? Going once, going twice. If not, I'll answer it. AWS calls it a network ACL. So because we're in the cloud, we're going to swap out the network ACL for the ACL. No. Does anybody think we can do 802.1x or private VLANs or any of this stuff in the cloud? No. So all this great, seriously heavy-duty security we have in the cloud goes away. I mean, in the data center, you can't do it. You just don't have that grade of security in the cloud. Now, on the cloud, what could we do to keep traffic from entering a server in the first place? Is there something that keeps traffic out of a computer or a server in AWS? And if so, what's that called? What is that thing that you put that's stateful, that acts almost like a host-based firewall, that keeps traffic out of your service in AWS? Can anybody tell me? Comment it in the comment box. If you don't know, I'll teach you. But comment in the comment box. How do you protect an instance? How do you keep traffic out of your virtual machines on the cloud? What is that special service called? It's called the security group. Wonderful, Francisco Suba. Guys, let me know you're here. Okay, we're going to use the security group. Okay, now everyone, let's see. Would it still be a good idea to have the host-based firewall again? Anti-malware protection and disable unnecessary services and patch these systems? Yes, we still need that. So, how do you do storage encryption on AWS? What is that thing you have to enable? Begins with key. How do you secure your systems on AWS? How do you encrypt your data? Network security groups, John, is an Azure thing. We're going to get to Azure too, don't worry. We're going to cover lots of clouds today. You can see my associate Chris added some information for our training. If you're not one of our students, we highly recommend it. Okay, so Suba, nice job. We're going to enable the KMS, or the key management system. And that key management system is going to do wonders for us. It's going to be fantastic. That key management system is going to do the following. It's going to encrypt our data. Okay, so what does every major enterprise use for IAM? They use Microsoft AD. So what is that service in AWS cloud that lets you federate your cloud with Microsoft AD? What's that thing called? AD what? How do we federate our stuff? AD what? What's that service called, everyone? To federate our identity systems, part of our security architecture. Microsoft AD is the service. What is that service used in AWS to federate to Microsoft AD? AD what? If you guys don't know, I'll help you. We're going to use AD connector. No worries. That was pretty easy. Maybe we should map out our servers for the cloud, for the web. Web stuff's going to be easy. Okay, now we're on AWS. Jeannie, we use AD connector to connect to Microsoft Active Directory. You guys are doing great. Okay, now let's take the web tier because we're going to copy it in AWS. Let's first start with a load balancer. Does anybody know what AWS were to call a load balancer? We're going to, in Greenheart, we're going to use Microsoft AD connector, connect to Microsoft AD. What does AWS call their load balancer? You know, it's some ridiculous term that they made up, which makes it much more complicated to figure it out because they had the word elastic. What does AWS call a load balancer? What is that load balancer thing called? Anybody? Going once? Suba! Nice job! An elastic load balancer, great job. Cashel Coastal, wonderful job. Have a red stripe beer for me tonight. Leo, great job. Remy, fantastic. You guys are there. Let me know you're here. Want to know you guys are awake, alert, and oriented? Good job. Let me know. Okay, fantastic. So we're going to swap out this with an ELB slash NLB. Good job, guys. You're translating an architecture for the cloud. Look, you don't need to know which service. You can Google the service. What you actually need to do is know what you're trying to achieve. That is the secret to success here. What are you achieving, and go after it. Go get it. So, awesome. Now, does anybody know how you would find a web server like this? Well, what I would do if I was you, I would go to the AWS webpage, and I would look for an EC2 instance that has 128 cores and 4 terabytes of DRAM. And if any of you do that, you'll be able to find one relatively quickly. You don't need to memorize this. Don't memorize this. This stuff changes every day. So when you're dealing with this kind of high performance stuff, make sure you get it. So you're going to have to swap it out. So with AWS, I happen to know this. Why do I know this? These are the only servers I ever work with in today's world. Is these big AMD EPYC servers with 120 cores and 4 terabytes of RAM. Why? Why is everybody using these, including Amazon? These things cost not much more than an Intel workstation, and they have like 5 times the performance at the same price. So these AMD CPUs that are each $8,000 will pretty much outperform a $60,000 Intel Platinum CPU. So 2 of these things, you can get a really good server for $30,000 that will do about as well as a $300,000 Intel server. So everybody's using these things now. Everybody's using it. So because of this, I can tell you these servers on AWS are called an X1E.32XLJ. Now, you can just look it up. You don't need to know. Now, wait. We need another load balancer. What does AWS call them? They call it an ELB NLB. Okay, fine. Let's translate it. We need another one of these. Got to make it work on the cloud. Okay, so app servers. 128 cores, 4 terabytes of DRAM. Isn't that the same one here? For our NoSQL data, Apache Cassandra databases, 120 cores, 4 terabytes of DRAM. X1E.32XLG. Now, will these systems on the cloud perform as well as our system in the data center? No, not at all. Why? In our data center, we're running on native hard drives. We're running on native hardware. There's no hypervisors. There's no virtual drivers. Our systems will, at minimum, for the same size server, give us 10% better performance in the data center and the cloud. But this is the best we have. So, do you think we might need more servers in the cloud to handle the same load? We might. About 10% more. But that's okay. We can do it. So now, let's look at the rest part of these modules. Let's look at the remaining components. Our trading servers. What would that be? X1E.32XLG. Same ones. Now, here's where the magic's going to happen. You need a GPU optimized instance on the cloud. What is that really going to be? What does it mean? Now you got to go to the AWS store and you got to look up GPU optimized instances. Somebody go out there, not me. Somebody tell me what is the absolute best, highest performance GPU based server you can get on the cloud. Somebody go to the AWS. Let's look at a GPU optimized instance. Now, mind you, our current servers have 6 Quadro 86000 cards. So, what could you possibly find on the AWS plan that'll get close to it? What possible compute instance could you have? What's going to equal these kind of things? Anybody have any ideas on what they could possibly use? What gives us equivalent performance to what we have? Okay, I'll help you guys out. So Amazon has this EC2 P4D instance, which is a high performance GPU system designed for machine learning. Okay, so now we mapped all this stuff out. Now before we get to the BGP, what we want to do, excellent job. It's a P4D, it's a P4 instance. Great job, Francisco, you're doing fantastic. Great. Now we also remember we want to host the website in Azure. So let's now map these compute instances to Azure as well, because that really matters. So, everybody, now this is Azure. Azure is not going to do the GPU instances, just the website. So let's talk about that. Now, what does Azure call a load balancer? Much more specific, much more logically organized than AWS. They call it an Azure load balancer. Now, all you really need to do if you understand architecture, you need to know nothing about Microsoft. Nothing, zero. All you need to do is look up what has 128 cores, what has 4 terabytes of RAM. Why? This is the architect piece. So I happen to know, because I teach my students so much, that this is an M128S instance. What do we need? Another Azure load balancer? No big deal. We'll use an Azure load balancer. 128 cores. M128S, same thing. Guess what? For these things, for the database servers, again, an Azure 128S. Is it complicated? Of course it's not complicated. It's the same thing. So let's do this. Now, we've got this stuff in AWS. Is this stuff is this stuff connected on the internet? Or do we need something special to connect this to the internet? What do we need to do to create a public internet connection for our servers? Somebody tell me the 2 things that we need. One is basically the equivalent of an internet-facing router, and the other is a public IP address that needs to be placed somewhere. What do we need to create our website on AWS and connect it to the internet? Guys, comment in the chat box, please. Comment in the chat box, and we will do anything we can. What's that special thing we need called? What is it? What is the router that connects to the internet called in AWS? Well, Philip Houston, if we use NAT, basically NAT will translate our private addresses to a public address, and our our web servers won't be reasonable to the internet. Francisco, great job. We need an internet-facing router, which is called an internet gateway. So we're going to add an internet gateway. Mandar, excellent. Internet gateway is a router. So we add our internet gateway. Now, excellent. Our devices need a default route to the internet gateway, right? Okay, so we need the internet gateway. Suba, Route 53 is DNS. Can I build a complete and total website and just connect to it via its IP address without DNS? The answer is 100% yes. We don't need DNS. We will use DNS, but it's possible to build everything here without DNS. So we'll use DNS for lots of reasons when you integrate it, but DNS is mapping a name to an IP address for the most part, and some health check stuff, which is cool. So we also need a public-facing IP address. If it's not publicly facing, it's not reachable. So basically, your internet gateway connects you to the internet. Now, because you're connected to the internet, you still got to connect to the web servers. Now, you've got 100 of these things. Are they all going to have a public IP address? Or are you going to put a public IP address somewhere else, like the load balancer? You're going to put the public IP address on the load balancer, and you're going to keep everything else private. So, what does AWS call their version of you borrow a public IP address? What do they call it? What's that thing done? What's that thing called? What is it? What do they call that public-facing IP address? Good job. Okay, Yogesh, you mentioned the Internet Gateway before. Yogesh mentioned an Elastic IP. Awesome. Amaranth, Elastic IP. Nick Love, Elastic IP. Awesome, 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 awesome. You guys get it. You're using an Elastic IP. That's how you're making these connections. So you're going to put an EIP or Elastic IP, which is going to be a public address that you basically, so you need an EIP. And basically you need this route. It's going to be a default route that points to the Internet Gateway. The default route looks like this. It's okay, Ryan. Leave your stuff there. It's okay not. We're all learning here. Everybody's learning, so if it's not right, that's okay. Ryan, you're doing so good. I mean, for your age, the things you've learned and the speed you've learned it, you are just awesome. You don't have to remove stuff. If it makes you feel better, sure, but you're doing great, Ryan. So we need to have a default route. What is the default route? A default route says if you don't know where to go, go here. And that's what a default route is, and a default route's going to look like this. It's going to be here on the network load balancer, and basically it's going to be planning unknown traffic, go to the Internet Gateway. Okay, now you guys got it. So this is what you need to do to connect this. It's pretty easy. Don't worry about it, Ryan. Seriously, I'm super impressed you're doing fantastic. My associate Chris just put in the chat box. Like you mentioned, we have a 250-hour completely comprehensive training program to take people from wherever they're at and turn them into cloud architects. We love working with people. Chris put the link for that, as well as a coupon code. I will put our number in case you've got questions for our office as well. Now, we're going to get into some fun traffic engineering. We're going to talk about some BGP, and this is, near and dear to my heart. But before we do that, we've been talking for a while. I want to give you guys 5 minutes or so, 7 minutes to ask any questions. Do you have any tech questions thus far? Give you guys a minute or two for questions. If I don't hear any questions, that's also totally completely fine, but I just got to know. So, also, while I'm waiting for you guys to ask questions, I'm supposed to ask if you're enjoying this content, please leave a like and or subscribe to the channel and or hit the bell to be informed of new free trainings, which are going to do many more coming up soon. So please subscribe and hit the bell and leave a like if you're enjoying this. Any questions for me before I go back to the content? If so, we're going to have some real fun on BGP. Any more questions? Just trying to make sure we don't miss anyone. So, we still need an Internet Gateway equivalent, John, on Azure. Actually, Y1, our program, specifically speaking, to answer your question, most of the soft skills training is done by you doing specific projects and presentations that you actually turn in for feedback, so that typically doesn't affect you. We typically do most of our in-person training that we do online together is architecture for about 80% of it and 20% soft skills. And Taurus, will this video persist on YouTube after it's ended? The answer is absolutely yes. If you guys learned a lot, we want you to be able to share this content with others. We want you to invite people live, be able to share it. So this particular content, we're going to leave it to persist on YouTube. So you'll be able to access this again in the future. YH, we address every student on a particular case-by-case basis. You may have certain things in your life that preclude you from doing things. There may be workarounds that are specific for you that are different for other people. I don't feel like it's appropriate to air your personal situation and everything about it in a group setting. I will happily have a conversation with you, and we can definitely help you. And you can call our office at the following number. Lots of other people work full-time. Lots of students are there, and we are more than happy to address it. If it's just the soft skills, we've got other ways that we can work with just soft skills training with you in a program or in a soft skills related coaching program. So there's lots of specific ways we can do it, but I need to know exactly what's going on in your life, exactly what your career is, your career goals. You being an architect, you want to be a leader, so all these kind of things. So it's a much deeper conversation than something we can have in a chat box if we're coming up with special things just for you. I hope you can understand that. The special things that we do for one person may be completely different from other ones because you all have different goals, you all have different jobs, and you all have different experiences. So the soft skills that you would need if we're going to create something custom for you are going to be different than somebody else based upon your background and experience. So because of that, that's why we need to have it with just you. But you've got our phone number and we're happy to help you. And love to work with you. We can help you in a lot of ways, but I really need to be very specific when it comes to things that are outside of our normals. Most of our students attend our classes, and maybe they attend the first 30 minutes of the class, where we do some soft skills, or hour of the class. Maybe thereafter, when we focus on the architecture, they watch the replay. So there's lots of ways we can work around it for someone's situation, but I don't know your exact situation. I don't know what time zone you're in. I don't know any of that. So because of that, I'd love to answer you, but I got to be very specific to you because you're coming at it from a very non-standard perspective. So I hope you can understand that. Please feel free to call us. I will happily have a 15 to 30 minute conversation with you to work around the situations exactly for you. Any other questions before we go on to the next, before we talk about how do we do traffic engineering? And before they do that, John, tell me, you seem pretty smart, John, tell me on the Azure side, what is an Azure Internet Gateway and how do we get a public IP address? And then we'll complete the Azure one. Okay, and then Jeannie asked a question, what is a demilitarized zone? So while I'm waiting for you, John Oho, to look up the Azure Internet Gateway and public IP address, or anybody else that wants to do that, let me answer Jeannie's question, what is a demilitarized zone? So typically speaking, this is your internal network. Here's the internet. Mr. Singh, Naman Singh, Mr. Lion, whichever you choose to prefer to go by. Definitely familiar with the culture, the warrior culture of that. But, you know, I don't know what HLO means. So if you could spell it out, we'll be in great shape. Hindi is totally fine. I have no issue with Hindi. In fact, when I teach yoga, I actually teach it in Sanskrit, which Sanskrit is obviously different than Hindi, which is different than Sindhi, which is different than like Malayalam. I'm very familiar with these worlds. And that's fine, but acronyms are something you really want to try not to use whenever possible because there's like 10 acronyms for the 10 meanings to the same acronym. So if you just help me out, I'll help you. But in the meantime, I need one of you guys to tell me what is an Azure Internet Gateway equivalent. Not a VPN gateway, just an Azure Internet Gateway. And I also need an Azure Elastic IP address equivalent, like an external IP address. So while you guys are looking up that, we're going to answer Jeannie's question. So she asked, what is it? So typically speaking, this is what your network would be. Azure VNet. Great job, Suba. Now, Suba, tell me if we need a public IP address, and if so, where do we get it from? Because that's going to be the second half of this project. Where are we getting these public IP addresses from? So let's now look at this. So this is what it typically looks like, Jeannie. We've got the internet. We've got the firewall. The firewall blocks, literally speaking, everything. Nothing is allowed past the firewall coming in. It blocks everything. Now, let's say, Jeannie, you wanted to put some web servers out there. Let's say your web servers are sitting behind your firewall in your internal network. Let's just say over here, let's say we've got our web server. This now means that, I want you to understand it completely, Jeannie. We have the internet, we don't have a DMZ, we breach the firewall, we allow the firewall to actually let people reach port 443 from anywhere in the internet and port 80 from anywhere on the internet. Now we basically have 2 ports open to our entire world and our internal network. Basically, we've got anybody that can come and do a web request and get in our network, they've bypassed our firewall. Does anybody think that's a good idea? So obviously we need a static IP suba, but what's that actual IP called? Do they have a name for it, like a elastic IP address, or they just call it a public IP? Azure typically uses much better names. So now let's go back to this environment. Jeannie, when we opened up our firewall, we have our web servers in the internal network. Now our internal network's open. Does anybody think that's a good idea? I don't. I don't want to open my internal network just for the web servers to be reached. So instead what we do, Jeannie, is we create something called the demilitarized zone. And what is the demilitarized zone? That's an area that, basically speaking, and Rob, check it out. If it's virtual IP is what they call a public IP address, find Azure public IP address. That's what you should be looking for, or look for Azure elastic IP equivalent, and that's how you're going to find it. That's how you go from one cloud. So now, Jeannie, let's say you decide to put your web servers here. Now, here's the process. You allow them to come in from the internet, hit the firewall, and you open up the web ports, meaning port 80 and port 43, and you only let them reach, those ports are open only to reach the web servers. So now what you have in the demilitarized zone, Jeannie, is you've got access to your systems. It's protected partially by the firewall, but the firewall will allow web traffic. Now, the firewall is still blocking any external traffic coming in. So your web servers, if they're hacked, can't reach your internal network because they're hacked. They're outside your firewall. Your web servers are partially protected, meaning they're owned by the firewall and that they'll only allow, say, port 443 and port 80 in. But everything else is blocked. So by putting them in a DMZ, you basically can create an environment where you can put your things that need to be publicly facing in an environment where they're reachable while simultaneously keeping them from being reachable on the internet and by your internal network. So that's the point of a DMZ. So, okay, guys, you did pretty good. So let's fix the Azure. Azure VNet is your internet gateway. And guys, 2,000 plus people have been here at some point during this call, 2016. So while I'm answering questions, if I miss something, just, remind me. Because it's pretty hard to do both at the same time. And what I mean by that is as follows. So let's do this. What do we call that thing? We called it an Azure... what do you call it? So we've got an Azure VNet. And from here, we're going to have static public IP. Now Azure is connected to the internet. Now, Yogesh, I'm not sure what your question is. If you're asking how your DMZ is implemented, are you asking me how to configure a firewall? Because we're architects and we don't really configure things. Or are you asking me how to design the DMZ? Implementation typically means engineering. We teach architects. Architects don't configure or code or do anything related to anything other than design and plan the best way to design these end-to-end systems. Like what we're doing today takes a lot of skill, but architects don't configure. So if you're asking me how it's implemented, do you mean we set up a Palo Alto firewall and then teach you how to do it? Sure, we could do that, but that's not really architecture work. And Jeannie, you're more than welcome. If you want to know about DMZ design, happily, oh gosh, do a live stream for DMZ design. So if anybody wants a security architecture DMZ like 3-hour presentation, and you want it live and you want it free, pop it in. Type DMZ security architecture design, and we will focus on just that. But it's going to take a few hours. And if you want that, we'll do it. I might even walk you through some firewalls while we're at it. So if you guys desire that, you guys let me know. And Yogesh, I will happily do that. And if we have some time left over today, I'll do some more of it. But if you guys really want a good firewall instruction, how do you plan your DMZs and your routing in and out of them, I'm happy to do it. Happy to do it. Type in the box, Cloud Security Architect, and then I know you want to know that kind of thing. So if you type Cloud Security Architect and there's over 50 people, we will do it. Ned, so good to hear you. See you're here. So if you guys want that kind of DMZ architecture design, put either DMZ architecture design or put Cloud Security Architect, because that's all Cloud Security Architect training all the way, and I love teaching it. We get 50 people, there's 70 people on the call, we will definitely do it. Of course, my phone will be ringing every day for the rest of the week, and that's okay. Any day we can help the Cloud Architect community, we love to do it. Me or someone from my team will speak to anybody to make sure that we get you guys to your goals. So happy you're here, Ned. I know you're working full-time, and you attend our classes while you're managing a large team of people, and you attend our YouTubes and some of our free courses, and Ned, we're always grateful to have you, and you've been a fantastic student, and I've got the biggest expectations in the world for you. Okay, I'm starting to see some people coming in for DMZs and Cloud Security Architect work. I get a couple more, and we'll do one real soon. While you guys are letting me know, we're going to get to some BGP traffic engineering in a minute, and it's going to be awfully fun. Awfully fun. So now we're going to get into the CCIE level routing and switching. So let's talk a little bit for a few minutes about what is BGP. And in order to do that, and why is BGP used? And apparently my hair got all kinds of crazy while I've been making this presentation. So apologies for that. So what is BGP? Because you're going to need this for the next part of this discussion. BGP is an exterior gateway protocol. What do I mean by exterior gateway protocol? It's used to connect to external entities. So in the beginning of this, if you'll recall, we used our interior gateway protocol to set up our high performance routing, meaning routing that will heal itself in seconds, instantly. That's what interior gateway protocols do. They're designed for speed and performance. Exterior gateway protocols such as BGP are designed for scalability. So inside of my internal network with an IGP, I might have 5,000, 10,000 subnets, and that's about as much as you're going to get, maybe 20,000 before your IGP falls apart. But when you connect to BGP to an external router, you might take 10 million routes on a single router or something. Now you know how scalable BGP is, so much more scalable. Now, why else do organizations use BGP? In our environment, we use this OSPF network, which is a link state routing protocol. What happens here? Every router tells every other router about every link that it has. And then the routers themselves run what's called that shortest path first calculation. It uses the Dijkstra algorithm. And then it says, link here, link here, link here, link here, recalculate route and find you the best path. Fast, it's good, but it doesn't scale. It's not meant to scale, it's meant for an entity. And because everybody's saying, here's my links, here's my links, here's my links, guess what you know? You know about everybody's links. Now, what if you didn't want to know that? What if you only wanted to allow access to one network, or two networks, or three networks? You can't do it here. Now, what if you wanted to manipulate your traffic? Now you're changing with like an IGP such as OSPF or intermediate systems to intermediate systems. Now you're changing metrics on links, and that gets ugly, really ugly. You want to break your system, start changing metrics on links, start changing your timers, don't do it. So BGP is super scalable, designed to connect to external entities. When you connect your data center, internal to AWS. External, that's why you use BGP. When you connect your system to two internet service providers and you want to load share, you're internal, they're external. That's why you're using BGP. As I mentioned, external BGP is used to connect to external entities. Internal BGP is used to connect to your own organization. So BGP is used for scalability, tunability, and performance. Specifically, how do we handle these routes and how do we filter and compute them? So now let's talk about load sharing. Now let's go back to our problem here. We've got in this environment, let me show you my screen real quick. In this environment, we want to load share across equal cost links in BGP. Now, I want you to really think about this. We're going to map this problem out very carefully before we go back to this. If I've got 4 equal cost links, I go out one link. My traffic might come back on another link. Now, if I've got a link that goes out Verizon and it comes back on AT&T, this isn't so beautiful because Verizon's latency might be different than AT&T's. So this is called asymmetric routing. It comes in one way, goes out another way. This is not good. Not good at all. It's even worse if I send out data on AT&T and it comes back both on AT&T and Verizon in the same time. Which means if there's different latencies on the links, the packets from Verizon might come back faster than AT&T. Now I've got all kinds of packets going out. My data is coming out completely out of order, and it's ugly, ugly, ugly. It causes all kinds of problems. So we're using BGP for these reasons. BGP specifically because we can tune it. That's the whole primary reason we use BGP and scalable. Look, all these routing protocols are pretty reliable in the way they work. Whether you're using OSPF, which is probably super reliable because the constant hellos, which basically are like a health check. Hello. 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 You miss a couple whole times, it recalculates. BGP uses a TCP connection, which by inherently makes it reliable. But we're really using BGP because it's tunable. So now let's look at how we can do this. Let's pretend we're going to just go to 2 links because this is going to get complicated looking at this together. So let's make this simple and elegant. We're going to start with the easiest way to load share this, and we're going to progressively get into more sophisticated routing. First thing I want you to look at it is this way. In order to make BGP tuning, you must have an intelligent IP addressing scheme. You know, we have not designed an IP addressing scheme to our system, but we're going to do it today. We should have done it in the beginning. But teaching a large audience, our audience, at this point 2136 people have actually been part of this, and we're thrilled to have you here, so just understand what it is. So now let's look at it. Let's say on this side, everything is constrained to 10.0.0/8 world. And then let's say that everything we have here is constrained to the 172.16.0.0/15. Okay, so, excuse me, I'm going to sneeze. Excuse me. I have lots of allergies. About 6 months ago, or a year ago now, I adopted a little kitten. This little kitten was a gift from my wife. I picked up this little fluffy thing. It sat with me. It literally spent the last 9 months in my lap. Sleeps on my feet every day. I'm highly allergic to this wonderful little girl, but she's like the daughter. She's sweet and loving, so I sneeze all day because of this cat. Well, I guess we make choices in life, and I like the cat more than I like my allergies, so I just deal with it. So apologies for the sneezing. So let's look at it this way. Let's look at these subnets. Let's say here you've got 2 subnets, 172.160.0.0/15, 16, and a 172.160.0.0/16. As you can see, thank you so much, Ryan. As you can see what we did here, we've got a summary or a CIDR range that includes both subnets, but these are 2 very specific subnets. Now let's say here you've got a 10.1.0.0/16, and let's say you've got a 10.2.0.0/16. Does everybody see the following? Does everybody see on the left side that 10.0.0/8 encompasses 10.0.0.1 and 10.1.0.2? Okay, so Suba, thank you for letting me know. I'm sharing my screen again. John, oh, thank you for letting me know as well. So look at the screen right now. On the data center, we've got a 10.0.0/8. What does that really mean? That means what you can see is as following. You can see the 10.0.0/8 goes all the way from 10.0.0/8. Thank you, Zakai. To all the way to 10.255.255.255. That's what those range encompasses. So 10.1.0.0/16 and 10.2, thank you so much, .0.0/16 is still inside of that range. Now let's go to the AWS side of it. 172.0.0/15 encompasses 172.16.0.0 and 172.17.0.0. So now let's play. Here's where the fun begins. Routers and routing protocols do the following. They pick the most specific route, the number one, that's the decisioning tree. So which is more specific? 10.0.0/8 or 10.1.0.0/16? Well, just look at the subnet mask. Got an 8-bit subnet mask for one and a 16-bit subnet mask for two. The 16-bit subnet mask is a more specific route. So now, from the data center, if on the data center you took 10.1.0.0/16, and on the bottom link, you told AWS to reach 10.1.2.0/16. Now, and you send these routes through a BGP route advertisement. So you send it over here, you send the same route, you send a different route over here. Now, on everything's working perfectly. AWS wants to reach 10.1.0.0/16. Which link's it going to take? Anybody know? It's going to take the top link. And guess what, everybody? If it wants to reach the 10.2.0.0/16, which link does everybody think it's going to take? It's going to take the bottom link. Does everybody understand this so far? Because after here, we're going to get into the complexity. So please let me know you know it, because after this, we're going to get into some CCI level traffic engineering. Please let me know if you guys got it. So far, so good, Leo. Awesome. Somebody else let me know. Leo, you're good. Does everybody else understand this? This is really important because we're going to build on this fast. We're going to get some heavy-duty networking. Can somebody else let me know if you guys got this? Okay, so Amaranth, yes. Francisco, yes. Thomas, let's do it one more time. A router will always take the most specific path. So let's take it out of networking for an example. Path 1 is to Mike's street. Path 2 is to Mike's house. Going to Mike's house is more specific than going to Mike's street. So that's non-networking. So let's do this. Let's look at John. I'm glad you're good to go. So we're almost there. I'm just going to do it one more time for the people that are new, because then we're going to build and escalate fast. The more specific your route, the more accurate it actually is. So Ryan, I think you're in Montego Bay. So if I know how to get to Montego Bay, that's great. What if instead I knew how to get to your house? Which is more specific, how to get to your house. So now let's look at routing information. So how do we get to your house? Well, you've got two things. Let's take an aggregate or a CIDR range. The CIDR range of 10.0.0/8 encompasses everything from 10.0.0.0/8 all the way to 10.255.255.255. So it accomplishes all of them. So it encompasses 10.1.2, 10.1.0.0 and 10.2.0.0. Now, if you guys don't have a big background in subnetting, Chris from my team, a few weeks ago, we did a 4-hour subnet workshop. Chris from my team is going to paste that link in here so you guys can get some accurate subnetting. Chris from my link, come, then I recommend every one of you that's not our students, join us for tomorrow's How to Get Your First Cloud Architect Job. We're going to teach you everything you need to do to get hired. So recommend everyone Chris put that there. But Chris is going to put a link to the subnetting one. But does everybody see how, oops, didn't mean that to happen. I don't even know what happened there. Does everybody see now that 10.1.0.16 and 10.2.0/16 are actually contained in 10/8? Does everybody see how 10.1.1.0 is also is very accurate to get to one destination, and 10.2 is basically saying, so if I've got 2 routes to my house and I say, to come to my back door, take path 1. To come to my front door, take path 2. Does everybody understand that so far? It's more specific than just saying, how do you get to my house? Everybody getting that? Because I can say, my house has reachability 10.0.0/8. My front door is 10.1.0/16. My back door, which my cat uses most of the time, is 10.2.0.0/16. Is that clear how it's more specific? Please let me know in the box. I'm going to make sure most of you guys get it, and then I'm going to progress forward very fast. Okay, you guys are getting it. Good. So, now, I want you to work through the next problem with me, everyone. Now, let's say I lose this link at the top, it goes away. Do I have any reachability to 10.1.0.0/16 since nobody else told anybody else? God, I'm so happy you got it, Ryan. So happy. So does everybody see? Now, we removed the top link, meaning the link went down the BGP pairing session. The only route we know about right now is 10.1.2.0. Can we reach the 10.1.0.0/16 subnet right now? Everyone, tell me. With this link down, which means the route advertisement is gone, can we reach it? If we lost the link, and we don't have a route to 10.1.0.0/16, and all we have is a route to 10.2.0/16, can AWS reach the systems that are in the 10.1.0.0/16? Anybody know the answer to that? If you don't have a route? If you don't know, I'll answer you guys, but I want to get you guys involved. I want you guys to love this, learn it. I want you guys to be network experts. Know the network, know the cloud. Cloud's just a virtualized network and data center. Leo, good. Reginald, no. You don't have a route, you can't reach it. So, what did we do here? Let's go back to the architecture of what we've done. Because this is high-end routing architecture. This is Cisco certified internet expert level work. And you need to know this as a cloud architect. So, now, so right now, the link's back up, everything's working. Is there any way that we can provide backup services while still preferring preferred links? Well, yeah. Now let's explore this. Now let's say we have both of these links, and in addition to the specific subnet that we actually put what's called a summary or an aggregate route. And let's say we pop this on both links, on both BGP route advertisements /8. So let's make sure we've got our specific route and our summary route. On the bottom, we've got a specific route and a summary route. Now, which paths are going to be used? Like when everything's good, I'm going to tell you right now. The only traffic that you're going to use if you have these two subnets is the top link AWS is going to use to reach 10.1.0.0/16. And AWS is going to use 10.2.0.0/16 on the bottom link. Does that make sense to everyone? Because it's the most specific path. Please tell me you know this. Or if you understand it. If not, I will cover it one more time. But does this make sense to everyone so far? The path is done, and each path is going to take the most specific link. You guys got me? Please tell me so I know you're here. I want you guys to learn this. This is really important stuff. So, I haven't heard anything from people. Then again, there's also like a 90-second delay between by the time I say something and the time you hear it, so I'm not sure. So, okay, now. So remember before, Leo, you got it. Koshel, Coastal, awesome. Nick, love, you got it. Okay, so you guys are getting this. I'm really excited. You guys are literally doing CCIE level routing with me right here on the spot. So you guys are doing great. You guys are going to be great cloud architects someday. Or network architects, whichever you guys desire. So now let's have some more fun. Now let's remove the top link, which means the route advertisements go away. No more of this. What's in this bottom link? No. This bottom link says, hey, to reach 10.2.0.0, take me. And oops, hold on. And on the bottom link, what else do we have? We've got this 10.0.0/8 on the bottom link. And because I typed it improperly, oh, well, this is not a marketplace thing. This is BGP. It's a routing protocol, but, you know, lots of cool stuff come from the marketplace. So awesome. So let's doing all the security stuff. So now we've removed the top link, and on the bottom link we have the 10.2.0/16, and we also have this 10/8 subnet. Now on the bottom link we know how to reach anything in the 10.x subnet range, and we know how to reach this more specific route. So, you know, Ryan was over there in Montego Bay. Koshel is over there. I believe Adriana's also coming in from Jamaica, not Montego Bay today. Ian, my student's probably here, is Jamaican. So let's just say everybody's connecting to here. We've got some Jamaican people that are connecting in today. We're having fun. So now, let's look at it. We can reach the bottom link. So can I now reach the 10.1 subnet, even though I don't have a specific route advertisement for it because I've got the 10.0.0/h? Can everybody know that I can still reach that based upon having a summary route or an aggregate route? And what this route is, it's a route to Mike's home. And inside of Mike's home, Mike's computer room exists. So the 10.2 is how do you get to Mike's computer room. The 10.0.0/8 is how do you get to Mike's house. And once you're in the house, you can walk around and explore. Can you reach it now? Come on, guys. Tell me. I want to make sure you guys get this. Because BGP, we're going to have to apply it in two different directions. And then if you guys get this, then we're going to do some really cool, fun traffic engineering policy stuff. So let me know that you guys are solid here. Tayo, Gene, and Yusuba, great job. Okay, you guys get it. So now you know that we have a preferred path when things are good, and we have a backup path when things are good. Amrath, good job. You guys are doing great today. So the next thing that we have to address along the way. Our routing's up. We got it. Do we need to determine the traffic in and out of our systems with BGP, or can we apply it in just one way? We've told AWS how to reach us. Do we know how to reach AWS yet? Okay, Reginald. Do we have AWS knows how to reach us? Because we sent them the traffic. So AWS knows how to reach us, but do we know how to reach AWS? Did we get any routes from AWS? Did we learn anything from BGP yet? Or did we just send them routes? And if we just sent them routes and they didn't send any routes, and we don't have a route to a destination, can we reach it? Okay, good. Ned, we've got to do it in both ways. Taurus, we've also got to do it in both ways. Tayo, you're correct. We can't possibly know how to reach AWS. And why can't we? Because they haven't sent us any routes. We've got to do our routing in both directions. This is not an IGP. This is an EGP. So we must, because we don't have reachability. So now what do we need to do? How do we fix this? On the AWS side, we got to do the following. So let's say we do this. Let's say on the AWS side, on the top link, we put 172.16.0.0/16. And we also put the summary route, the one that provides reachability for both subnets, 172.16.0.0. Oh, hold on. So 172.16.0.0/15. That includes all of them. So on the bottom link, what are we doing over here? We're going to provide access to the 172.17. So now when AWS comes and reaches us, let's make sure we put the routing here, because this is going to be version way that we can traffic engineer. This is going to be the simplest and most elegant. After this, we're going to get into some complexity. Lots of complexity next. This is the simple part. So, I just want to make sure you guys all get it. So, with this, AWS is sending us on the top link the 172.16 as the primary path. On the bottom link, it's sending us the 172.17. More specific. So what does that mean? We're going to use 172.17.0.0 on the bottom link, and we're going to use 172.16.0.0 on the top link. Now, if one of these links goes away, do we have reachability through the 172.16.0.0.15? Yes, we do. So now we've got perfectly engineered traffic to get point A to point B. You've got some good security concepts such as key management and encryption and IAM. In this particular case, we're actually talking about routing, which is a different topic. It could be that your video is actually displayed and you're still looking at the security component and not the routing component. So these things happen all the time when you're dealing with tech on the internet. So we understand that you're doing good. Happy to have you. You're doing great. This is some pretty complicated. That's what we're into CCIE level routing. This is way outside of the average cloud architect or solution architect world. But you do this kind of stuff in a job interview, and not only will they hire you on the spot, but they'll pay you a whole lot more than if you didn't know these kind of things. So that's what we're doing it. So does everybody see how we've set this up? You guys understand this? Because now we're going to start doing BGP traffic engineering the complicated way. This is the simplest and most elegant. While I'm waiting for you guys to answer, Lokesh, you were asking about our Cloud Architect Challenge that we do on the 10th. We don't post those Cloud Architect Challenges publicly on the internet. If you want to join one of those Cloud Architect Challenges, Lokesh, you got to register for one. I will pop the link for the registration for them, but we don't publicly post them. Okay, you guys got it. Leo, you got it. That's how you join the Cloud Architect Challenge. Jeannie's got it. Reginald's got it. Okay, great job, guys. This is exciting. You guys got the foundations of BGP. Now we're going to tune it a different way. This is the fun stuff. So, let's do it. Now that we're having fun with BGP, now let's start getting into some depth here. Let's bring this to the bottom. Let's chalk these whiteboard sessions. Do you guys learn when we do these whiteboard sessions? My goal is I thought, I could produce a bunch of BGP documentation and push it out there, and then you can't ask questions. And we're exploring, as a company, doing a tremendous amount of live stream, potentially even purchasing a professional streaming setup with specialty cameras, specialty lighting, backgrounds, and audio goes. Would you guys like us to do a couple of live stream sessions a week dedicated to your cloud computing career? If so, let me know in the chat box, because we're exploring doing that as an organization. I'd love to know your feedback. Tell me that, and then we're going to get into some fun BGP traffic engineering. You'll definitely be able to impress your friends, other cloud architects, And even your friends that have been working in networking for a long time, unless they're CCIEs like me. So I know there's a huge delay, and again, I'll be sneezing because of my beautiful, beautiful, beautiful kitten, Cindy. She's the best thing ever, but I'm highly allergic to her. So if I sneeze, my apologies. Are we all caught up? If you guys would like us to do more educational live streams, please let us know. Tarsus, you said yes. Or Tarsus, you said yes. We need to know from a lot of people if that's something you guys desire. And if you guys desire it, I'll make a point to try and carve out some more time in my schedule, which I don't have, to do more live streams. I really want to make sure you guys get everything you need to be wildly successful. So, if I get a bunch more people requesting live streams, we'll do a lot more of them. Now, before we get into the BGP content, if you're enjoying our content, please leave a like and or subscribe to our channel. I hate being Mr. YouTube, but I want to make sure that people know about us so that we can help as many people as possible. So please leave a like, a comment, forward this kind of traffic to someone else. IO, there's an extremely large delay in the messages between you and I. IO, I am not ignoring any of your messages. IO, you're fantastic. There's some kind of delay going on from our messages to your messages. So much so that we're talking about networking and you're talking about authentication and load balancers. And we're actually talking about routing protocols, which means somewhere along the line, IO, because I know you, you are incredibly smart and a wonderful, wonderful guy. We've got some kind of streaming problem between your house and my house. So I'm not ignoring any of the things you're talking about. We'll make sure we cover these things on Friday internally for you. You're an incredibly smart guy. I'm not ignoring you, but there's got to be some kind of thing. You've got to be looking at a different part of the presentation than we're talking about because of the extensive delay. Ahmed, yes, our course is extremely intense, and even our free stuff is intense. Our paid stuff is obviously much deeper than the free stuff, but we like to connect with people and help them any way we can. So now let's talk about other ways to tune traffic engineering. So let's talk about some other cool ways to do it. So now, if you didn't want to get involved in more specific, less specific routing, and I got to tell you, this is what Bassam Halabi recommended 25 years ago, that every CCIE was read his book, and we've all been doing this. There's lots of other ways and tools that we have to use. So let's talk about those other tools. Now, let's say we want to use just the more specific routes. Well, actually, we're still going to need the summer route. But let's say we only wanted to use, instead of doing a more specific and a less specific, let's say we want to prioritize something over something. So let's say, well, actually, let's just send specific links on both. Let's do it this way. I'll show you how we would do this the other way. Now, it's going to be a little more complicated, but it's totally feasible. Let's map out our subnets, 10.1.016. So let's pop this down here. Oops, that wasn't supposed to work that way. Bear with me while we clean this up. Okay, so now we've got specific routes on the top and the bottom link. Thank you so much, Jeannie. Really appreciate your kind feedback, kind words, and been so wonderful to work with over this time. I truly appreciate everything, including sending me some sparrow and Burberry from Ethiopia. That was so wonderful because it's the food I eat all the time. I think I'm half Ethiopian Rastafarian in my own world, so completely appreciate that as well. So thank you, Jeannie. So now let's let's go look at this from another perspective. So right now we've got the same links on the top and the bottom, which basically means we're leaving it up to chance. There will be a preferred path and there will be a non-preferred path. And what will happen is these routers hold elections, and in the end, there's a way you can prioritize your traffic, but there's a way, it just does its own. In this particular situation right now, if I've got the same links on the top and the bottom, chances are it's going to go out one link and back another, like this. We're going to have asymmetric routing. Is asymmetric routing good for anything? Not unless you want out of order packets. It's a problem. So how else could you manipulate? Okay, BGP. Prefer the path to the most specific route. Prefer the path with the largest weight on routers that support weight. Prefer the path with the largest local preference. Prefer the path with the lowest multi-exit discriminator. Well, there's an algorithm there. Preferred one option, preferred two option, preferred three option. What could we do? Okay. Now, what if we did this? What if when we received the, actually, now we're going to, so in this particular case, I'm only going to show you on one side to make it look a little prettier. What if, this is the route that we received from the data center. We may go back to this because we really need to do this in both directions, but I'm not sure if it's all going to fit on the page, so we'll temporarily remove it here. So these are the routes you're receiving from AWS on the top link. And guess what? Let's do the same thing for the bottom link. Let's get rid of all this stuff because it's going to be in the way. We probably are going to do this in just a single direction to try and make it easy. And now let's look at this. So now we're receiving the same links from AWS on both sides, the same subnets. Again, out of order packets. Big problem. But what could we do? Could we change the weight, for example, through BGP policy, and change the weight to, say, 40,000 over here, versus we'll keep this, I think it's a 32538 or something like that. I haven't been configuring routers in a little while. I have to check up the actual default one, but prefer the path with the largest weight. Now, on the bottom, let's say we do the same thing. Let's say on the bottom link, which is the one we want to prefer, we set that weight to 40,000. I think, and then we just set the top on to basically something less. Let's say 32538. Now everyone, prefer the path with the largest weight. Prefer the path with the largest weight. So, AWS, what is AWS going to do? They're going to look at this route and they're going to say 10.1.0.0, weight of 40,000. I've also learned this route on the bottom, 10.1.0.0/32538, which is a bigger number, the top one. So AWS will, by default, use the top link for the 10.1 subnet. Now, which has the higher weight for the 10.2.0.0/16 subnet? The bottom link. So AWS will constantly use the bottom link. That's exactly what's going on. Top link for the most specific subnet, bottom link for something completely different. And that's how you traffic engineer. Now, let's remove the bottom link. And let's remove all the routes that we learned from the bottom link. Do we have full connectivity to every subnet on the top link? Yes, we've got them all. So what did we do? We basically said subnet 1 go over one link, subnet 2 going on the other link. Now BGP is bidirectional, so we must do the same thing on the routes that we learned from AWS. Identical. Okay, now, let's have some more fun with it. Let's play with it. More options. Networking's cool. Love networking. There's always another tool. It's like jujitsu. For every move, there's a counter move. For everything you want to do in networking, there's a way to compensate it. We've got tools in networking. That's why the CCIE that I did, when I did it, I had to read 75,000 pages of reading just to take this exam. I also spent, about 2,000 hours doing practice labs before I could even take the exam. That's why in networking it's so big and complicated. That's why people like the cloud, because the cloud's simple. So much of this stuff is done for you. But I promise you, as a cloud architect that knows these things, your options will be 10 times more. People will fight to hire you, and they'll be fighting over what to pay you over the long term after a year or two's worth of experience. So become great. Learn these communication skills. Learn the network, learn the data center, learn security. Let people be into a bidding war over you. You'll never be in a position in your career when you're this good where you won't always have multiple offers that you can use to negotiate higher salaries. Just make sure you're great. It's networking. So now we did the weight. What is on that list? Prefer the path that's most specific. Prefer the path with the largest weight. What's next down on our list? Local preference. Local preference is next. So, how do we do this? Let's see local preference. So, the default local preference with the Cisco router is 800. So now let's take this subnet. Let's say we're going to use this. Let's make this local preference 200. Let's make this local preference 100. Let's make this local preference for the 10.1 100 because we want it to be unprioritized. And now let's make this 200. Okay, now people tell me, prefer the path with the highest local preference. Somebody please tell me which is the preferred route on the top link versus which is the preferred loop on the bottom link. Route by the bottom link by taking the prefix and matching it with the higher local preference. Somebody tell me this. Somebody tell me which link's going to be used for what based on local preference. Somebody type it in the chat box. Type me the specific prefix 10.1.0.0/16. Tell me link, top link or bottom link based upon the local preference. Somebody tell me which link. Somebody help me out here. Which is the preferred route based upon the local preference being 200? Anybody? Anybody? Which local preference is higher, 200 or 100? The 100. Nick Love, which path is preferred? Prefer the path with the highest local preference. So which subnet is going to be preferred on the top? Ginny, you are right. The local preference of 200 is going to be chosen. So what's the subnet next to the 200? Reginald, top link, 10.1.0.0/16. Excellent. And that's going to be used for that because, like Jeannie said, it's got a higher local preference. And on the bottom link, the preferred path will be 10.2.0.0/16 because it's got a higher local preference. Okay. Does that make sense? First, we chose the path with the highest weight. Then instead, we manipulated the local preference. Now let's take the shortest AF path. So, let's say this AS. Okay, Francisco. So, weight and local preference are typically set on the receiving side. Now, on the receiving side, what you would typically do in a router is you would set up a route map, and you would say you would typically match a certain prefix and change the weight. Now, Francisco, there's a couple ways you could also do this. You could have your provider set a community for a certain route, like a BGP community, and you could then create a route map that basically says, for this BGP community, change the weight or local preference. So I can basically create an agreement with my upstream provider, and I can say, here's community 1, here's community 2. Please match this community and change the weight or local preference to manipulate. But I've got to work that out with my service provider first. But you can change weight and local preference are set on the receiving side. Great pick. Now we're going to do something that's very different. This can be done on the sending side or the receiving side. So let's say this is 65312, and then let's say this is 65313. Let's see, these are autonomous system numbers. Now let's look at it this way. When I receive a route, as it stands right now for all these things, I'm going to see an AS path and it's going to say 65312. This is what we're going to really be seeing for both of these routes. And it's going to get so ugly with all these little arrows here that I'm going to just start removing arrows. Remember, these routes are coming from the data center. Okay, so here we're going to do this. Now, right now we're going to make equal cost AF paths. And then we're going to do the traffic engineering. And I'm going to show you how to do it on the sender end, or the receiving end, but then I'll show you how you do it and tell you how you do it on the sender end. So, because this could be done either. Now, in this particular case, I brought you back to all equal cost routes. Everything's the same. Everything is equal. So it's all equal cost routes. Hope you guys get that. Now, what if we want to make one link look ugly and another link perfect? So let's say we want 10.1.1.1 to use the top link and 10.2.2 to use the bottom link. What could we do? We could prepend or add AS paths, making it look further away. So now what prepending does is it just adds the same AS path number. So now let's say we receive this route. Now let's come back to this. I want you to come back to the system after we prepend our ASs. And after we prepend our ASs, here's what we got. So now look at it this way. On the top link, which is shorter? So each AS path is an additional hop. At least that's the way BGP looks at it. So on the top link, I'm 1 hop away for 10.1.0.0/16. I'm 2 hops away on the top link for 10.2.0.0/16. On the bottom link, I am 2 hops away for 10.1.0.0/16. And on the bottom link, I am 1 hop away for 10.2.0.0/16. So what are you guys going to do? Which one do you guys choose to choose? Which one has the shortest AS path to 10.1.0.0? That's going to be the path chosen for this. Somebody tell me in the chat box, which path is going to be used? Anybody know? John Oho, fantastic, great job. The shortest AS path wins, yes. So now, John Oho, because you are really right, and I'm loving this, which route is chosen for the top link and which route is chosen for the bottom link based upon the shortest AS path? John, you're right. I just want you to actually know the top link, the bottom link, make it clear to everyone, and then after that, I'm going to show you how you do it on the other way, on the other end. Because John, you're right. Top link is the shorter AS path to which subnet? 10.1.0.0/16. The bottom link, oh John, you got it. You got it. Awesome. Wonderful. John, you know the top link and the bottom link. You figured out the shortest AS path. Francisco, you got it. Jeannie, you got it. Wow. You guys are doing CCIE level networking inside of 4 hours. Wow. When I go to sleep tonight, I'm going to be really excited by seeing some of my students like Jeannie literally going through CCIE level routing. Ned's doing it. Reginald's doing it. You know, so many of my folks are doing it. I'm super excited. So for my internal students, great. And for those of you guys that are not my internal students, you guys are doing great too. So welcome, welcome, welcome. We love working with you. So excellent. Now, let's look about this a little different. Here we've got a little more control. When I'm sending the route to AWS, for example, I could just prepend it on the sending side. I can prepend it when I send it directly to them. I could take my subnets and prepend them. So I can do this on the sending side. I can do this on the receiving side. Does that make any sense? Well, I can do it on the sending side. So when I send you routes to my service provider, if I don't want them to take a certain link, I can just prepend or add autonomous systems, and then the service provider's routers are going to say, If I have nothing specific with the service provider, and we have a standard BGP pairing, and I want one link preferred over the other link, guess what? Super easy. What do I do? Really easy, easy, easy. I prepend it to the service provider, and I can manipulate inbound traffic into my network by just sending them prepending. So this is how we tune it. Now, there's lots of things, highest and lowest IP address of the router, but there's really one way that's highly tunable. Oh, John O, you're officially our student. I am super excited to work with you. You're already doing great on the networking side. You must have just signed up, and thrilled to work with you. So, look forward to seeing you in our class on Friday. It's going to be our internal class, and we're going to have lots of fun. We're going to also do some free stuff. Our free things can never be anywhere close to as deep as our internal things, because we have to give our students an extreme competitive advantage over the competition. But we still want to raise the level of the community, even our free community, to be better than everybody else. We just want our students to be the top 1% of all cloud architects. So that's the way we run our company. We still try and take everybody and make them better than anybody else's students. But our internal students, like you, you'll get to see what you get to do on Friday, and you're going to have fun. So welcome, John. So, great job. So now we can send it to them. Now, does anybody remember prefer the path with the largest weight, prefer the path with the largest local preference, shortest AS path, lowest multi-exit discriminator? That's another thing we can tune. So let's do it with MED. So what is that now? What is, so typically speaking, if I remember correctly, the official MED, the standard MED on a Cisco router is 100. But I work with lots of different routers and lots of companies. I work with Cisco devices, Juniper devices, Riverstone devices. I work with every network device you can, and they all have slightly different formulas with regards to defaults. And things like weight are typically Cisco proprietary, although it's now being supported on other people in AWS, but weight is not available on all routers, so just know that. So now let's change the MED. So let's do this. Prefer the path with the largest multi-exit discriminator. MED 50, MED 100, some people call MED metric. It's like a metric. So MED 100 up top. Abbas, you know, I got to tell you, if you're in the Middle East somewhere, or somewhere, and you're here with us, I got to tell you, I love your fight and your commitment. I've worked all over the world. At 6 o'clock in the morning, I'm speaking to folks in India. At 8 o'clock in the morning, I'm speaking to some pretty amazing folks in Africa and Europe. And sometimes super earlier than that, I'm speaking to folks in Asia. And let me tell you, I've spent a lot of time in lots of parts of the world, and I really respect your effort and fight to be here, so thank you. I hope we're making it worth your while, you being up this late, Abbas. And we're very grateful and honored and privileged to have you here. Shukran. So now everyone, when we look at this, the top link, which has the lowest med? On the bottom link, which has the lowest med? So in the same situation, which link is going to be taken to reach the 10.1.0.0 subnet? Somebody please tell me based upon which has the lowest med. I know there's a huge delay on this link, so I totally get it. Which one is going to be the link chosen for 10.1.0.0/16? Okay, Iskar, we will get to your question in literally 1 minute. So, Mr. Khan, I've got you covered. Let's just finish this one particular thing, and then let's address any career question you have. I promise you I'll give you as much time as you need. So 2 minutes, let's just finish this. Which link is going to be chosen for the top? Okay, good job, the /16. Reginald, good job, you got it. Why? Because it's got the lowest med. I'm totally blown away. You guys are doing fantastic. Super excited. Okay, now, Mr. Khan, you have a question that you say is urgent regarding your cloud career. Now, tomorrow we are going to have a completely live, just to let you know, how to get your first cloud architect job, and we're going to cover cloud careers and every one of them in depth. We will cover everything you need to know, how to interview, the required skill sets, and how we build them, and how you can work with us or on your own. So that's going to be there for you. Chris from my team has popped a link. I believe that's pasted to the top. But got some questions. I've been going aggressive. More BGP, more BGP, more BGP. Please ask your question now. If anybody has any questions, we'll answer some more questions, and then we'll figure out where we need to go to make sure everybody's learning. So go ahead, Isra Khan. What question do you have? Thrilled to answer your question. Just let us know. You can ask any question you want, Mr. Khan. We're here in support of the cloud computing community, please, or network architect community. Okay. What about associate degree in networking and a CCNA? I'm not sure what your question is. Okay, Mr. Khan, I'm going to tell you this right now. Your age has nothing to do with it. Do not quit. Are you looking for a networking job or a cloud computing job? I will tell you this, Mr. Khan. We remediate people that come from the cloud computing programs, these 2-year programs, every day. We also work with lots of people that have been training in the cloud. What does it really take to be moving to these cloud roles? I'm going to tell you, and then we're going to go back to this. It requires extreme technical competency. That means, from a network perspective, somewhere between a CCNA and a CCNP. You must know traffic engineering, like what we're talking about today. You must know NAT. You must know optimizing routing, QoS policies, VLAN, private VLANs, .1 Q tagging, Q and Q tagging, Ethernet over MPLS, WAN optimization, SDN wouldn't be a bad thing to know. You need to understand how firewalls work in depth and how you deploy them, how IDS, IPS systems work, all the kinds of authentication systems in the cloud. You need to understand Active Directory. You need to understand servers, virtualizations, containers in depth, in extreme depth. You literally probably also need to understand the lamp stack in depth, how it works. Not how to build it, but how it actually works. From there, you're going to have executive level communication, meaning how do you speak to the CEO and ask somebody, Mr. CEO, you run a $50 million or $50 billion a year business. What are your business pain points? What are your business goals? What are your challenges? And from that, you need to be able to think about a technology solution that's going to solve their business problems. Then you need to be able to think about how do you take their network in the data center and move it to the cloud, because that's what the job is. So you've got to have deep understanding of the network. And I got to tell you, I love the CCNA, but it's not enough. We're talking today about like minimum level of network knowledge. We're automatically already in between CCNP and CCIE level knowledge. So there's that. And then you must work with VMware or KVM. You must know how to build containers because it's part of the knowledge. Then you need to understand firewalls, and so how do we build the competency with our students? I'm going to tell you right now. Twice per week, we have live architecture training sessions. Now our training is 250 hours a week. And tomorrow, if you come to our class, you will be able to ask live questions and I'll be able to build the perfect plan for you. I want you to join. But because you asked a question, I want to answer it anyway. Twice per week we do live training. We do 3-hour architecture training sessions like this, but our architectures are much more complicated. Today what we're doing is more networking. So we do this twice per week. Then we've got about 30 hours of AWS training, about another 50 hours of cloud computing training, and a good 100 hours plus communication work of soft skills, emotional intelligence, presentation training. So our training is between 250 and 300 hours after somebody's AWS certified. So let's say we had an AWS certified solution architect professional. They still need about 250 hours to get hired. They must be competent. They must know the network, the data center, and how all these systems work. Knowing the name of a service like S3 and how to configure it, cloud architects just don't do. They do the kind of stuff we're doing here today, evaluating business requirements. But you not only have to get the requirements, you're going to be fine, ISCAR. We've got, like I said, we do this every day. I've got 60-year-olds that have no problem getting jobs. No problem whatsoever. And guess what? They have never had worked in tech either, and it's still not a problem, but you have to know the whole thing from end to end. Why did I do so much free training on the internet? I'm going to tell you right now. The AWS certification courses have zero to do with the actual job. Literally speaking, zero to do with cloud architect roles or solution architect roles. They do help prepare people for junior cloud engineer jobs, meaning how to configure things, but completely unrelated. That's why we've released so many free ebooks. That's why there's a free AWS Certified Solution Architect ebook. The link is in the description of every video we have. Why else do we have, realistically speaking, what do we do next? We provided free Certified Solution Architect videos, advanced networking, and professional, because you need that. But then we teach in depth. So if you want to get there, Mr. Khan, we can get you there. I am happy to get you there. If you've got real in-depth questions, you can literally call us and we're happy to speak to you. I'll put in our phone number. We deal with this situation every day, and tomorrow we'll get you off mute. We'll get your questions answered and we will help you build the plan. And if you'd like to train with us, we'd love to work with you. And if you want to train on your own, by the end of tomorrow, you're going to know exactly what you need to do to get hired. That's our How to Get Your First Cloud Architect Job webinar. It is completely free. I know it's listed at the top, but there are so many things that are literally speaking so hard to find. I am going to pop a link to this. Am I in Bahrain? I am not. I have spent a tremendous amount of time in UAE and loved every last minute of it, but I am actually in Palm Beach, Florida, or right outside of Palm Beach, Florida, USA. Okay, so let's see if anybody else has any questions. I want you guys to truly get it. I want you guys to be exceptionally good cloud architects, have a great cloud architect career. If I can ask you one more time to leave a like and or subscribe, or share this thing with other people that you feel will be helped. Don't ever let anyone tell you can't do something in your career. The only thing stopping any of us is our own minds. There is nothing you can't do. You know what my world looks like? Oh, okay. So my country code is actually 1. So when you start seeing the 1973, it's actually not a country code. The 1 is actually, so if you desire to do that, here's what I'm going to do. Let me do this right now. Chris from my team posted a link to the course, but can I share the session for the Zoom link? What has to happen is you have to fill in that registration, the link that I just sent, and when you fill in the registration, what will happen is we will email you with the link and the course. So that's the best way to do this. So for your question, Mr. Khan, I'm going to put a link to our program, and I'm even going to put a 20% coupon code for you too. Chris from my team would normally be doing these kind of things, so I can focus on teaching. He had to pick up somebody from the airport or something like that, so all's good. I'm going to try and pretend to be Chris and teach at the same time, which is not very easy. Chris is super smart. So, well, tomorrow, Mandahar, we've got 2 sessions tomorrow. The first session in the morning is going to be how to get your first cloud architect job, and I promise you will learn a lot. I'm actually doing another session with my friend Sandeep Das in India. So there is so much confusion between a cloud architect and a cloud engineer, and a cloud architect and a DevOps professional, and a cloud architect and a SysOps professional. The next meeting, Zoom meeting, is tomorrow at noon. So tomorrow we're going to do this. You take that webinar. You're going to learn a lot on that webinar tomorrow. Actually, you know what? Make it easy. I will just pop a link to the Zoom webinar if that makes it easier for you for tomorrow's. Actually, you know what? You've got, my team reminded me, you've got to go click that link and register, and that way we keep track of who attends the webinars. Okay, so Chris from my team can make sure you have access to anything, but you also have my phone number, and I provided a link to the course as well as a coupon code. So, who has the next question? While we're waiting, in case she has a chance to see it, a huge congratulations to my video editor Manuel, who's in Colombia, and she's out on maternity leave. So congratulations, Manuel, if you've seen this video. We are super excited. Your baby is absolutely beautiful. Is Harkan, what's the best time and number to reach me? Honestly speaking, there's no good time to reach me. I am booked up from morning till night. What I've actually done is I've set some time after this class. So, 5 p.m. when this is over, so you want to give me a call, give me a call. I am free from 5 p.m. to 6 p.m. today. And Eastern time, so as soon as this is over, I will have a phone and availability for about an hour. So if you need to call or anybody wants to call, that's probably a good time to do it. Otherwise, send me a text message and I promise I will call you back. Just tell me your time zone, where you're at, and we'll make sure we get in communication with you. Or you can also email admin at Go Cloud Careers. That is monitored by our senior staff. And when I mean senior staff, I'm talking about data scientists with MBAs. So that's what we use as customer service, because we want our students to have the best experience. Chris will respond to those messages, and so the question is, so Ramchar, Tuesday at 9 a.m. is for the Cloud Architect Challenge. That is next week. Mondays, we do a How to Get Your First Tech Job webinar at 9 a.m. Eastern, which is 2 p.m. England time. On Tuesdays, for free, every week, we do a Cloud Architect Challenge, where we basically give you the challenge to see if you're ready for a Cloud Architect job. We will make you interview me, like you would in real life as a Cloud Architect. You will interview me. You will ask me my business, legal, technical, regulatory requirements. You'll ask me about my current systems and my goals, and you'll design a solution for in the cloud to do that. They get people from all over around the world, and they have a lot of fun, and they send me beautiful emails afterwards, so you're invited for that. On Wednesdays in the morning, we do a Cloud Architect Career Question and Answer session where we answer any kind of question you need about cloud computing careers. Then on Thursday at noon Eastern, which is 5 p.m. UK time, We do a How to Get Your First Cloud Architect Job webinar. And tomorrow we're doing another one. In the morning we'll do we'll do a friend conversation with my friend Sandeep Jazz, and we're going to talk about how do you become a cloud architect versus how do you become a DevOps engineer. I want everyone to know that these careers are completely different, but I also want my cloud architects to at least know what DevOps is. And DevOps professionals need to understand what architecture is. That's the extent of the knowledge you need in DevOps to be a cloud architect. Like, you should know what it is, because you're going to be designing end-to-end systems. And when you're dealing with end-to-end systems, guess what? You need to know all this stuff that's there. So there's there. So I hope I answered your questions with that. Now, who else has more questions? Because we want to answer any question you might ever have. We really want to help the community out. We love this cloud architect community. I took my first tech job. My first one was technically 1993. By 2000, I was working on the frame relay cloud. Guess what? By 2002, I was working on the ATM cloud. By 2003, I was working on the VPLS cloud. Then we would design clouds for cloud providers. This is my whole life, so I'm excited to be here. So it's my life's work. Practiced medicine first, left medicine, went into tech, and never looked back. So this is my life's work, so I love being here. So ask any questions you desire. Any more questions? And I know there's a massive delay between me and you, so I totally get it. I'm sure you've got some more questions. Feel free to ask them. Ask more networking questions to clarify, career questions. I've got 17 minutes left, and I'll do anything I can to help you guys. Any more questions from anybody? You guys getting tired? You guys ready to get some rest? I get it. Okay, 2 questions. Mr. Khan, how much time is our course? We typically would turn you into a cloud network architecture as opposed to a cloud network engineer. We focus more on architecture careers. It's probably a lot easier to learn to be an architect than an engineer, and the pay is double. So we typically focus on architects. It depends, Mr. Khan, on how much experience you have. If you've been working in tech for a while, it's about 4 months. If you've not been working in tech, it's a good 6 months. But we do it all the time. With that, we'd have to upgrade your network knowledge to Cisco Certified Network Professional knowledge, and it would look good if you got a certification in that too, and we'd give you lots of coaching on the way. It would also be good to get you the Certified Solution Architect Professional. That's the minimum level of certification to realistically get a job in today's world. It didn't used to be that way, but what happened is these Udemy course providers and the exam dumps created these incredible courses that could teach anybody to pass an exam and still not know anything about cloud architecture. There's there. So I'd say for someone with a associate's degree and someone that's got like a CCNA, unless you've done heavy networking work in the past, we're probably speaking about 6 months, but we can definitely get you there. So the world is yours. GitHub, would you put it on your resume? I wouldn't put GitHub on my resume. If I put GitHub on my resume, it would have a massively negative impact on my salary and my career potential. And here's why. I'm an architect. Architects don't code. Architects don't configure. We design. So if I wanted to prove my architecture resume, I'd put architecture things in there. I'd be talking about system design and how things work. So the answer is yes, but don't put GitHub or DevOps or SysOps work if you want to be an architecture. Now, if you want to be a DevOps professional, the world is yours. Sure, get there. It's great. But what's the job you want? If you want to be an architect, put architecture things. If you want to be an engineer, put engineering things. And if you want to do DevOps and SysOps stuff, put that stuff there. So I hope I answered your question. Mr. Khan from CCNA, If someone's a CCNA and they've never worked in networking, they've never worked with BGP, they've never worked with OSPF, they've not set up heavy-duty QoS policies, they've not set up NAT, they've not worked with BGP, it's the same as if they started from scratch. So CCNA is like introduction to networking, and we love that, and how to configure things. Int GE0/0, IP address 192.168.0.1, 255.255.255.0, no shut. Router OSPF 10. Network 10.0.0.0, subnet mask 0.255.255.255.0. That is CCNA level stuff. What we're talking about is designing the system, and because of that, it's going to be about 6 months if you've never worked in tech, 4 months if you've got a tech background. Even with the CCNA or from scratch, it doesn't matter. That's what it takes to be great. Michael, can you get cloud jobs without any college degree? Yes, you can. Michael, would you like to know what my degrees are in for fun? My first master's degree is in nursing because I was a nurse practitioner practicing internal medicine. My next one is in business. I've got no degrees in tech. I've worked in tech forever. I have maintained the most senior positions that you can possibly imagine at Cisco and other great networking companies, and I've done well with it, but it doesn't matter. So you can get a job without a degree. It makes it easier. So foolish hockey. How do you pass the AWS Certified Professional exam? Well, it's not that complicated of an exam if you can understand the cloud. So all of our students do it inside of our training program. I'll tell you this. You want to pass that? Take our Certified Solutions Architect Associate, then read our Certified Solutions Architect book. Then do our AWS Advanced Networking program. That's going to give you good fundamentals in networking, kind of like a CCNA class. Then when you're done that, do our AWS completely free Certified Solution Architect Professional Training, no big deal. And when you're done that, get a good practice test and get used to this ridiculous way that AWS asks questions. What do I mean by ridiculous way? It does not test you on your knowledge at all, that exam. When I take these kind of exams, what I have to do is I have to remember their entry-level exams. So let's say I'm going to go take the Google Professional Cloud Architect, which I've done, or the AWS Certified Solution Architect Professional. Here's what I do. When I take these exams, I work very hard to forget most of what I know. And here's the reason. What is typically done is not what a vendor wants you to do. So when I take an exam, I try to say, okay, this is the Cisco way. Nope. This is the IBM way? Nope. This is the Juniper Networks? No. What consumes the most services from a single cloud vendor? And that's typically your right answer. So just get a practice test, but you can easily pass these exams 100%, no big deal. All of our students do it inside of the training program while they're actually getting trained, so no big deal. And the next question is, should you prepare for AWS, Azure, or GCP? Well, here's what I would say. First certification should be AWS. Why? It's the biggest cloud provider out there. Next, personally, I like Azure. Why would I probably not do Azure and do GCP next? I look at supply and demand curves for my students for everything we do. And what's in the supply demand? What is the need versus what is the supply? I do this for as following. The more so Mandahar, basically speaking, we take people in with no background, we put them through our experience program, they get completely certified, they get completely cloud competent, and when they're done, they're hireable. So we know that even if you had 3 certifications, we're going to have to probably start you from scratch anyway. So we'd like to work with you from the beginning, and we'll get you to your goals. So going back to the supply and demand curve, if there's a huge supply of people, the cost of that person is less. If there's a huge demand and no supply, the cost of that person is high. So because we're concerned with salary optimization, we're always looking at these supply and demand curves. So what I would tell you, if you're looking for the best salary and the best career progression, I'd probably do the AWS one first and then get hired. Now, would I add over time a Google Professional Cloud Architect one? Maybe. But if I was really trying to build the best cloud computing career, the certifications are 10% and that's it, no more. I would do something like an MBA, for example. I would get better at business communication. I would get better at executive presence. I got to tell you, the difference between a $100,000 architect and a $400,000 architect is mostly communication skills, executive presence, and emotional intelligence. So am I going to get certified in 1,000,001 cloud providers if I care? No, I'm not going to do it. I'm going to focus on the high value target. Boost my communication skills, boost my presentation skills, boost my architecture skills, boost my ROI modeling skills, my executive presence, emotional intelligence. That's the secret to getting hired. And when you have no experience, here's what goes into an interview. So, of course, Michael, as I mentioned, you can get any job you want without a college degree. That's not a big deal. It will help long term to have one, but that's not the issue. The issue is as followed: can you do the job? And that needs a whole lot of skills that are outside of there. So, Fool Shocky, do I ever recommend AWS specialty certifications? Never. I ask my students never to do AWS certification exams. Here's the reason. AWS certification exams and Azure exams and even Google exams, because the Udemy course providers have created so many thousands of people that can pass these exams and still know zero, because the exam dumps out there, these AWS specialty exams are almost worth nothing. So, if I want somebody to be a cloud security architect, I make sure in my program they get a CISSP or a CEH and the Certified Solution Architect Professional. If I've got somebody who wants to be a cloud network architect, they typically do a CCNP and the Certified Solution Architect Professional. I don't have my students do AWS Advanced Networking. And AWS Advanced Networking is basically an intro to a junior level intro. That's it. That's all it is. A CCNP is how do you do the work. So we get industrial certifications that hold weight and big salaries. We marry them with the best cloud certifications. That's how we do it. That's why our students do so well. So Foolish Shaka, I hope I answered your question. So on the research and development section, the world is yours. Make sure you're putting on all the stuff that matters, like building a cloud. Michael, I answered your question. Foolish Shaki, I answered your question. Foolish Shaki, how frequently are proof of concepts need to be made as a cloud architect? I've done many in my life. Here's what a proof of concept is for like a distinguished kind of principal kind of cloud architect like me. I meet with the customer. I develop a design. I work with my design team to develop the design because no one person can do these designs. Then I bring on 10 to 15 people that set up the proof of concept. They're cloud engineers that build it for me. I lead them while they're doing the proof of concept. I'm the leader, the manager. Again, leadership skills, management skills are kind of critical. I'm an architect. I don't touch the cloud. I don't configure it, ever. I'm an architect. So, proof of concept means I need to bring in cloud engineers to go build it for me. As an architect, I am purely a systems designer. An architect will never touch the cloud, almost never, but they design it in depth. The only time as architects we ever get involved in even looking at the cloud is when we've designed like one of these solutions for which there's 20,000 subnets and 20,000 remote locations, and something's broken. We may get with the cloud engineers and help them troubleshoot it because we designed it. But they're going to be at the console. They're going to be looking at the command line. We're going to say, show me the routing table. We're going to look at it. We're going to say, show me the topology. We're going to look at it. We're going to evaluate data, but we're not going to touch stuff. We're architects, so no coding, no Terraform, no sysops, no DevOps, no anything. Design, design, design. Present, design. Document, design. Present, design. That's the whole job. 50% of the job is communication skills. 50% of the time is design skills, which in order to design things, you need to know extremely large amounts of how everything works. I hope I answered your question there. So Mandahar, like I mentioned, whether you have a background, don't have a background, we're going to start you off at the same place. Even if you had the certifications, we still have to start you out from the beginning because we know what it takes to make you great. So at the beginning, we build deep fundamentals just like we did today. We went from, basically speaking, from enterprise fundamentals all the way to senior fundamentals inside of 4 hours. Imagine what we can do with our own internal students that have gone through our training, that have our building blocks and fundamentals. Imagine what we can do in 250 hours, and that's the minimum of our training. The world is yours. Is an enterprise architect different to a cloud architect? Sure, a little bit. So let's draw the continuum. At the bottom right-hand corner, we have the most deeply technical, which is the cloud engineer. The cloud engineer is the hardest working, lowest paid person of the bunch. They sit behind a computer all day. Cloud engineers are smart people. Deep knowledge of how the services work and how to set them up. They build stuff. They're builders. Cloud engineers may need to script. They may need some coding. They need to know some Terraform. These are smart, smart people. And realistically speaking, that's what they need. Next, you've got the solutions architect. The solution architect is someone that knows a vendor, like AWS, and is an expert at designing just AWS solutions. Again, less technical than the cloud engineer by far, more understanding of the end-to-end, and maybe knows Azure or AWS, and that's it. Next up the link, with regard to much higher salaries, is the cloud architect. Cloud architect is a guy like me, and I've also been an enterprise architect, so I'm going to tell you the difference. A cloud architect is someone that's going to meet with the client like we just did today, get the requirements, design a hybrid cloud, multi-cloud, anything that's necessary, using any level of technology from any vendor, and develop the best end-to-end solutions. So, next up the link, and the cloud architect is going to be less technical than the solutions architect, but they're going to have much more business acumen, communication, presentation skills, and more knowledgeable end-to-end. And because of this, the salary from cloud engineer, solution architect, cloud architect. Now, I've been an enterprise architect. Here's the job. Working with senior leadership all day long. Optimizing the business through technology. This is an executive position. This is a $300,000 to $500,000 position. Enterprise architects all the time. So, cloud engineer, solution architect, cloud architect, enterprise architect. The more technical you get, meaning cloud engineer, the less you're going to be paid. The deeper your business acumen, communication skills, executive presence is, the more you're going to be paid. So, but you got to be technical first. If you don't have the technical fundamentals, you can't get hired. So we start with cloud architecture, solution architect roles. We move up to enterprise architecture roles, which I've done at Cisco. Great, great, great jobs. Just to let you know, it's a big, big continuum of architect roles. So, Ike Cole. There is a such thing as a cloud IAM architect. They exist all over the place. What does a cloud IAM architect need to be good at? First, they need to know the cloud, which is the network and the data center. You can't skip that cloud architect knowledge. Then, after you have the cloud architect knowledge, then you become an expert on, say, Active Directory. You become an expert with all the identity brokers that exist out there. Federate with Facebook, do it with this, but learn all the idiosyncrasies of it. Then learn all the integrations of, IAM. Learn how that impacts security. So that's what a cloud IAM architect does. We've worked with some in the past. It's a great career. It's not one that I typically do. I do it sometimes with people, but it's definitely there. The kind of architects we're used to working with are cloud infrastructure architects like me, somebody that focuses on the network. I was a CISP. Cisco made us all become security architects and do heavy security consulting too. So I'm equally happy in a cloud security role, but I prefer cloud networking because that's my world better. Then we have generic cloud architects that now kind of more of a jack of all trades of all kinds of part of the cloud when it regards to system design, not coding, not configuration, but design. Then we have cloud IAM architects that focus exclusively on IAM, and we work with them. Then we have cloud big data architects. These people could be focusing on databases in the cloud, or they can be focusing on machine learning kind of things. These are just some of the types of architects we work with, and there's jobs for every one of them. And the more specialized you are, the higher you'll be paid. Hope I answered your questions there. So, Nick, you asked the CISSP question. Nick, you're one of our students. I will address that with you on the Friday call because there's an official answer and a non-official answer. Okay, so we've run this until 5 o'clock. I have kept you guys from all over the world until 5 o'clock. I hope you guys had a really wonderful, wonderful, wonderful time. Tomorrow, like I said, we're going to have our completely free How to Get Your First Cloud Architect Job webinar. And we hope to see you there. We love providing free training. We're going to be doing that. I also listed a link to our course, which is here, for which we're going to close this. And here's a link to my number. There were a few people that actually were interested in reaching out to me. And I'm going to be in my office for the next, say, hour or so. So please feel free to do that. Thank you so much for all of you. If you've had a good time, type cloud architect. We're going to probably do a lot more live streams to try and provide more free community education. We want to really raise the level of the cloud architect community. Thank you all. It's such an honor to be able to communicate with you guys as often as I do. We love working with you, so please come back tomorrow. Listen to how to get your first cloud architect job for those of you guys that want to move to the cloud. Ike, hope to speak with you soon as well. Love talking to the community. So have a wonderful day, everyone. I really look forward to speaking to many of you soon. Got lots of free stuff coming up this week. Please be part of that conversation tomorrow morning. And Mr. Khan, yes, give me a call. Here's my phone number. Go ahead, give a call. I will be here after the call. There's some stuff that I've got to do on my end, which is extensive, but as it turns out, there's no day that ends at 5 or 6 o'clock at night for me, even though they all start at 6 o'clock in the morning. Wonderful. Jeannie Johnson. Yeah, go ahead, Mr. Khan. As soon as I hang up this call, please feel free to call. Alexandra, welcome. Jonah, welcome. Mandahar, so glad you're here. Sarah Smith, so happy you're here. That's a name I don't recognize, so please come back. See you all very soon. Take care, everybody.